Morning. Good morning, good afternoon, everyone. Good to see everyone here. We are back. SOC 100-1, Class 8, networking, more networking, lots of stuff to cover. Good to have everyone here with me. Good afternoon, good evening, depending where you are as well, too. But good to have everyone back. We're here for another round. Hope everyone's been doing well. Hope you all had a good week. And a little bit closer. Hope you all had a good week. Hope you've had some time to catch up a little bit, do a little bit of your studies on the networking side, review the material a little bit more. But good to have everyone here. Let's see who's inside the chat. Cool. Yeah, KS, Agile, Abe, Cybersec, Lint, DT, Finac, Cap, Karina, Pariah, Patricia, R Double, Steven, and Yurfom. Nice. Good little morning crew kicking in right now. Coming up to 20 people right here in stream-ish. Nice. Good morning. So we hit Twitch affiliate, by the way, everyone. So thank you all for doing this, for being here with me. So I haven't really looked at what the settings really mean for that. But you might see, like, I guess alerts might show up now. I think you can, like, use channel points. I haven't set that up as well. I think there's the, like, the Amazon Prime sub thing. There might be some things that pop up. So I apologize if something, like, kind of acts really weird in the stream. Just let me know. I'm pretty sure I turned off the random ads that might appear. There should be like pre-roll ads. So like when you join, I think there's that, but then I turned it off during the stream, so that shouldn't pop up. The only times that I think it should is when we actually do like a break. So I don't want to play ads while we're doing the content. That's not the point of this. So when we take an actual break, then an ad should pop up, I believe. So thanks, EDU. Thanks. Thank you. So let me know if something is blowing up on your end or something doesn't look right. If there's something new that's impacting it. Otherwise, I think we should be good. I think we should be good with that. So once again, thank you all for being with me here in the weekends. Cool. Thank you, Senpaiku, for that sub. I have no idea. I think something might have played. If you got an alert, let me know. If not, I need to get that set up. But thank you. Havana, good to have you. All right, so what are we doing today? Lab subject is no longer what is the internet. We're going to be doing a whole bunch of stuff. So we're doing IP. We are also doing subnetting, NAT, PAT, DHCP. What else are we doing? Let me take a look at my little agenda here. Oh yeah, we're gonna talk about appliances, collisions, and a little bit of VPNs. So we got a lot. Let's separate a bit. I'm pretty sure we're finally gonna be able to hit the labs today. It's just there's so much on the networking side. It is crazy. Like when you actually start going through it again, especially like teaching like a live class. Steven, yeah, I'm okay. So there shouldn't be ads like playing randomly. So let me know. I did disable automatic ads. It's not the point of these streams. This is supposed to be for a class. So I really don't want to get in the way of that. I think DT, that's a little bit more advanced. I mean, we're still like this is basic IT networking. So like I'm talking about like once we're through with this, like you should be like a help desk 1 analyst type of thing. You should be able to, that's what the point of SOC 100-1 is. So just understanding the process flows, the models, we got a long way to go. This is still, this is beginner, like this is entry level IT. Even though it sounds like we're covering a lot, this is actually still just entry level IT. Yeah, same, Finn. I agree. But yeah, how was everyone's week? Have you been able to catch up a little bit on the recordings, the videos? I know. Yeah, yeah, we can save the advanced stuff for extra things. Yeah, cool, Abe. Yeah, I mean, if you guys have pop-ups, that's fine. Like, you can just use an ad blocker. Danny joined the course pretty late. Karina still catching up, real life time, but yeah, I know it's quite a lot. So like, look at the stream calendar, kind of see where we're at. Get ourselves a bit of an orientation. So yeah, this is okay. Okay. So we are here. Like, today's November 9th. This is supposed to be class 3 of networking. And then we have tomorrow as well. Honestly, I think we're going to need to do another weekend of networking entirely. So what I'm thinking, and I'll kind of poll the audience, maybe here inside of Discord as well too. I am happy to do another stream around this time. It's just, I know some people take holidays around that time, so I don't know. But I'm okay with doing a continuous weekend stream over here and then adding in some more SOC 100-1 content, because I do want to make sure we're spending time with networking. And even towards, like, maybe we can fit like an extra day for like a 3-day type of stream or something around December. Cool, yeah, KS, you're good for November 30th. Yeah, y'all let me know. Y'all let me know. I'll do a good poll inside of Discord too. I like I said, I put that as a holiday because I just sort of like assume maybe some people take that weekend off. But Havana, sounds good to you too. Steven, catching up. So challenges are optional for now, okay? The challenges are optional content. You don't need to do them right away. You can come back to them. As long as you can get through the lab material and generally keep up, that's your target. And not only that, as a DT, you're good for November 32. Yeah, cool. Thanks, man. Yeah, I want to pull you on stream. I think I was hoping for this weekend, but I think we're still going to be like in the entry stuff. But just so everyone knows, like, DT is legit. This guy is very, very legit. Very experienced. Top brass over here. Talking like defending the nation type of top brass without doxing you. So I want to pull him on stream. He's one of the SOC 100 instructors. This is Doug. And he's going to help out with the Wireshark portion, actually doing some like packet analysis with y'all. So I think by the time, I think that's going to be like a next weekend thing. By the time we get through this content, I think looking at it, I think we'll be able to get to like maybe, I think by the end of this weekend, we should get through like towards ARP analysis and maybe a 3-way handshake or possibly to the HTTP requests. But I think next weekend we'll be able to do a deep dive into Wireshark and really kind of walk through it. You could spend a good weekend on it. I think we need to. I want you all to be proficient. We need to spend yeah, our double it down with the many streams as you could get. I hear you. I'm enjoying this. I'm hearing a lot of good feedback too, so I think I can maybe increase the frequency. And I'd rather spend a lot of time on networking. Cool, KS, yeah. So you got the entry ad. Yeah, pre-roll, you should like just have pre-roll when you join in, and then that's it. So yeah, what I'm thinking is I'm going to throw in like an extra 2 segments of SOC 100, one here, and maybe spread out networking a little bit more. Networking is like critical. I want to spend a lot of time on that. It's actually, in my opinion, even more critical than spending time on like the SOC 100-2 content, because that's where everything, yeah, maybe a bit of Zeke. Yeah, cool. Yeah, if you want to go off script a little bit and kind of show them off some fancy stuff, that'd be pretty cool. Hey, CI. So I think maybe we'll do that. We'll have like an extra 100-1 class, maybe 2, and then maybe pepper in some extra 100-2 content. Even somewhere like these holidays, these breaks, I think we can just keep doing them. I think we can actually just like stream essentially every weekend, except towards the end of December. Just about everyone's like on holidays towards Christmas time, New Year's and such, so... Cool. Okay, yeah, so I'll take a look at this, and then I'll also do a poll in Discord too, and kind of, I want to get some feedback like on time preferences, like is 10 to 2 p.m. Eastern still a good time on Saturdays? Does everyone like that? Maybe I'll shoot like an email and Discord, just like a big blast, like, hey, like, let's get a poll. So, okay, cool. We'll come back to that. Just a little heads up. Nice. All right. Let's jump into some stuff. Start doing things. We are gonna carry off with some more lecture again today. We do have some more lecture, and then we're gonna hopefully get into the labs by the end of stream, at least. That's the plan. So let's start off with common network appliances. Let's do this. First things first, because we've covered the OSI model at this point, we've covered DNS, we've covered the general process flow, like the model, like how this stuff actually works. So we've covered that. But now we need to start talking about the various devices in action, IP addresses as well too. We need to talk about how this stuff is actually connecting and working, and then we can start getting practical. So first things first. Let's go back to our old friend over here. Trying out a different program today as well. So let's see how this one goes. This one actually seems pretty neat. I can like search through text and stuff. So, all right. Let's kind of see where we left off. I can do like these little cool things now. So let's talk about networking and topology. This central node. And I'm going to slow down in my writing as well too with my notes and not be so chicken scratchy for you all, because you're liking it and I want to make sure it's more clear and legible. So we have a node, like our central node, and let's talk about a home network. I feel like this picks up the writing a little bit cleaner as well too compared to the other app I was using. Now this is going to be connecting out. Thanks, Karina. Yeah, this is much like cleaner compared to the other one. All right, so I should be able to make like a nice square. Yep, so this is like a PC. And this central node over here, right? We talked about this. This is like a star network. So let's go ahead and do that actually. Yeah, nice. This actually works out pretty well. Maybe not as nice as I would, but good enough. Okay. PC. So we have a star network at home. Topology. This thing here in the middle, as we talked about, is central node, but we haven't really got into it too much of what it actually is, other than this thing. Kind of looks like a bicycle wheel. Hey bro, morning. So this central node can be a couple things. And we're talking about like your home network. Okay, so we have a thing called, we've talked about this, but now we're actually going to get into what they are. We've talked about it. They can be a router. It could also be a switch. And it could also be a hub if you have an ancient network, or if you used to do LAN parties back in the day, busting out Unreal and Warcraft 3. And CS 1.6. If you used to have like an old hub at home, you'd have LAN parties and do that kind of stuff and hope for the best. Now, this central node can typically be one of these three things, and this is what I want to start you off getting used to, what these devices actually look like and what they are. So let's go and let's show what they look like. And you know what? I think I want to use more of like an industry one as well too. So I want you to actually see what they look like compared to your home. So you have these devices that look like this at your home. Maybe like this. Let's do this. Maybe like an ISP modem. This might be like something you have at home. A device like this. Yeah, we got some Cisco coming up, bro. So these devices, you plug in your Ethernet cable, and that is that layer 1 connection from your PC to your ISP modem. And what happens is you can then speak back and forth up and down that OSI model. And we can go from layers 2 and 3 at that point to speak with our MAC addresses and our IP addresses, which we're going to dive into both a little bit more. So if you're inside of a enterprise network, like business, they look a lot different. They look like these big, like heavy duty, robust machines. These devices, so we refer to these things as network appliances. Okay? And I think that's important to be able to mention. We refer to these things as network appliances, which act as nodes. A quick little refresher, remember what these nodes actually do is they act as these little connection endpoint, not endpoints, these little connection points throughout a network. And what they're doing is they're just sending signals back and forth from layers 1 to 3 for the most part. So Ethernet, wireless, and it goes up to the MAC address and to the IP address. And those are our addresses of our endpoints and our nodes on the network. Everything has an actual address. So we refer to these things as network appliances. And I really want you to remember that you're going to hear that term being thrown around quite a bit. Now, these central nodes have different purposes. And you've also heard the term modem. I'm going to put that over there as well, too. So let's go and kind of break these things up a little bit. You just got an ad on the left panel of the screen. You look and see where it's coming up from. You shouldn't be getting anything up on the left panel of the screen. Stream display ads. Okay, hold on. That's why. Maybe that shouldn't be on. Okay. So I missed that setting. Thanks for letting me know. Thanks for letting me know. Those shouldn't be on either. I'm trying to make this as like ad-free as possible. What was the ad anyways? Just out of curiosity, like what did it actually play? Did it really? Oh, wait. Actually, I shouldn't be asking this stuff. Like, don't dox yourselves. It's probably playing an ad of something that you've... Karina's been looking up for a Mac Mac Air. I think that... So, don't tell me what those ads are, actually. I apologize. I shouldn't have just said that without thinking. Those are your ads. Okay. So let's talk more about what these devices are, and it all starts with the modem. And the modem is a device and actually stands for Modulate, Demodulate. And what this does is it takes... So modem will go and it will take digital. It kind of does it both ways. So it will take analog and convert it to digital. And this is what computers all understand. We talked about this, right? The 0, 1, 0, 1, 0, 1. Analog is a naturally... It's not a digital signal. It hasn't been processed by electronics. These are frequencies that we find through nature. Consider analog to be like a natural sound. And that hasn't been processed through electronics and like computers and microchips. And what it effectively does, like I said, it takes your analog signals, like a natural signal, kind of like if you have a waterfall. Okay, and this is hitting a generator. Turbine, it's kind of like moving that water around. Right, and then you get electricity. You eventually create like these analog signals. They look like this in nature. They have these ups and downs. It's very... And depending on the frequency, they kind of change shape. So they kind of like... They may look like this. But that's a natural form of energy. And what this modem does is it takes that natural form of electricity or energy or a signal that we can create. And, you know, like, imagine, for all intents and purposes, if that's still, like, not clear. See this cup? And, like, if I'm hitting this cup, this is a natural sound. Like it's an annoying sound, but it's a natural sound. Okay, it has a frequency. Now, imagine this device, this modem, took that sound and said, okay, every time like he's hitting the cup, I'm gonna send like I'm gonna change the voltage to this high. And that's effectively what it is doing. It is taking this signal and it's converting it to a digital signal for computers to understand. PCs, electronics, they like that. And it does this both ways. So, modulate. And demodulate. So what happens here on this central node is your ISP, so your modem, sorry, not your modem, your internet service provider, they might send you a analog signal, or they might even send you a digital signal, depending on your connection. That goes into your network. And this central node acts as a modem at that point. And then it converts that signal into your internet connection. And it also sends it back. So this could be modem. Now, it's also going to function as something else. It's also going to function as this thing called a router. And before I go into that, is anyone unclear? It's essentially what a modem is supposed to be doing at this point then. Sure. So analog to digital means that we are taking a signal kind of like your cable connection to your TV or your phone line might be coming in. So your connection from your ISP modem to the wall, it's going to be taking in an analog signal, which is a natural form of energy. It's just electricity set to certain frequencies. And it kind of looks like this analog function over here. Now what happens is that signal comes in to your modem. This goes in, and when it hits your modem actually interprets it as a digital signal. It says, actually, you know what I will do? I'm going to actually show that a little bit differently. It's going to go down here. I'm going to show you an overlap. Oh, you know what? I'm actually going to do it like this. That's effectively what the modem is doing. It's taking that analog signal and it's looking whenever the signal is kind of going high and low. And this is a deeper, like I recommend if you want to get deeper into it, go and look up how like voltage and electricity works. But effectively, everything has a signal. And remember when I said like this cup? Imagine when I'm hitting my cup, that signal is going up. But when I'm not hitting my cup, that signal is down. Like you can't hear anything. It has to go down. Everything has this like high, low, high, low, high, low. That's like the natural, it's the universe. The whole world works this way. Every matter has like this form of electricity kind of going up and down. And we interpret that as a frequency. And when that cable comes from your wall to your modem, it's carrying that signal as a charge on it. And whenever the signal is detected as kind of going like high, it's going to interpret it as 1. So the modem takes that signal, says when it's high, that means 1. When it's low, that means 0. And then it feeds that connection to your computer. And that's how we know we have an internet connection of these 0s and 1s. So it's like Google Translate for your PCs. It's a translator. Yeah, it is a translator. It translates signals. That's effectively it. Cool. Good, good, good. Nice. So let's talk about a router now. Now, what a router's function is supposed to be doing is it is supposed to determine and detect when you want to send a signal outside of your network. And that's why you have an ISP modem that's also a router. So this is supposed to send connections. Oops. Beyond the network. So that is to say, that if we had this central node, if this PC wanted to go and reach this network, it needs to be routed. That's why we have the router. The router will send connections beyond your current network. It works up to a layer 3. It is a layer 3 device. And it forwards connections based on IP addresses. And that's important to remember. Remember when we talked about DNS resolution and we said, if I want to connect to google.com, and let's say Google's IP address is like 10.10.0.0 for all intents and purposes, and I want to connect to that IP address from my PC will speak to the router, and it's going to see, is 10.10.0.0 on my network? If not, I need to go beyond my network. So then it's going to reach out to the ISP. Don't know why that turned into that kind of picture. Second. Okay, I'm gonna play with that later then. Sorry about that. I want a plain long paper like that. What I want to demonstrate here is my PC. I want to go to web page. Google.com. Then step 2, we do the DNS resolution. And remember how that whole process works from last lab or last class? The router is actually involved in there because we don't know the IP address for google.com. So the router has to actually go and reach out beyond the network and find those DNS servers outside because it doesn't know what the IP is. So DNS gets resolved outside the network. And let's just say that Google is 10.10.0.1. Let's just say that's what it is. So now your central node gives you that IP address. Let's do a highlighter, kind of show how that works, kind of over here on this network. So let's say that PC 1, let's say PC A. Gonna need some color over here. PC A wants to connect to Google. We do the whole DNS resolution, so it's gonna go to your main central node and figure out, does this have the IP address? If not, go outside the network to the ISP. Once it gets the IP address, it's going to come back in and go back to your PC. And then finally, now that you have the IP address, you can go back to your router, go back to your ISP, and go to the Google servers and get the website information. And then it'll come back and go back to your PC. You see, it's just like a lot of ping-ponging back and forth. So a router essentially will just make sure that all those connections go back and forth. If the IP address or the MAC address is known within your network, it'll never leave your network. Your router will just, it's not going to do anything. It doesn't need to do anything. It'll just send the information that it has. If it doesn't have the IP address, it's going to go outside your network and it'll go to your ISP, to the internet and the World Wide Web. That's what a router does. It just sends connections beyond your network to other networks. All it needs to do. And this isn't a Cisco course, so we're not going to go deep into all the various different router protocols and optimization and speed and bandwidth and all that stuff. That's a whole deeper subject. You just need to understand for now, effectively, that is what the router does. That's its functionality. Does that make sense? Is anyone unclear on what a router does? While I try to find out why it keeps making these things over here. Ruled line paper. Some type of like default setting. What I didn't do is make. Does that make sense then? Any questions? Anyone on a router and its functionality at that point? Well, it looks like that got blocked out. I don't know what you sent over there, Steven, because it's all asterisked out in the chat. But I think, yeah, because you're probably blocked for sending links. Was that an IP address like 8.8.8 or something? So Karina, you're asking, is a router figuring out the IP? No. 911. Yeah, it works exactly the same, Steven. So your computer, if you're trying to connect to a DNS server to resolve domain names to an IP address, then it will try to find 1.1.1.1. Yes, that's where the router will send it to. It'll tell your ISP, hey, I need to get to 1.1.1. And then your ISP will send it out further from there. And then once you get the information you need, it'll come back to your router. And then the router holds that information and sends it back to your PC. And the router was figuring out so Karina's saying, you thought the router was figuring out the optimal route? Yes. That's exactly it. It doesn't figure out the IP. It figures out the optimal route to get to a server that knows the IP. Or to an endpoint that has that IP address. Yeah. That's its function. So you need it. Inside of any network, you're going to be needing a router. Or else you're going to have trouble leaving that network. Now, we have this other device. So now we have a switch. Got a message inside. Let me turn off my notifications. I think you might have. All right. So now we have these things called switches. And we're going to get later to talk about how IP addresses are actually sort of discovered. But now we have a switch that actually its purpose is to connect multiple endpoints together inside of a network. And it operates at layer 2. So this is to send connections from one endpoint to another. And just like how a router sends it by IP address, so the router does like source IP address to destination IP address. The switch does source MAC address to destination MAC address. So it does a lookup of something like, I don't know, source MAC to destination MAC. Like something like 0, 0, 1, E, F, I don't know, 5F. That's looking for 00.02.AA.B1, and these we'll talk about later, 4D. And all what it's doing is, this is also a central node. And it sits in the middle of the network as well. And it looks exactly, for all intents and purposes, it actually kind of just like looks like a switch. So we'll see. Same kind of like form factor and everything. Looks essentially the same. And the reason being is you're actually going to find, if you have your home network, chances are your ISP modem is also the router and also the switch. It's an all-in-one device. And Cisco has a form factor, like these major network appliance companies. They have a form factor to fit inside of server racks, and that's why they're designed like this. And you'll see that this is kind of what they look like. They have a whole bunch of ports in the back. So if this was a switch, all of these ports over here on this panel in the back would be Ethernet cables connecting in, and then those cables connected to different endpoint PCs, and then they communicate to one another via this switch. They send all those. Remember, we walked down the OSI model, so like from the application layer down, like HTTP requests to websites will be packaged up all the way down, and then your source MAC address of your computer is attached to it via encapsulation. That signal goes to the switch. The switch says, okay, that's coming from the source MAC address of like PCA, and it also has a destination MAC address wrapped on that as well, because that's where it wants to go. That's where your computer is trying to send it to. And then the switch says, okay, who on the network is this destination MAC address? And the switch stores that information. It actually has like a table inside of itself of data. Imagine this switch to be like a small computer. And it has like a little bit of data inside, and it stores all the MAC addresses for all of the endpoints inside of a network. And that's how it knows where to send it to. And if it doesn't have the MAC address, it will ask. It's going to go through all of the ports, and it's going to ask each of those computers through another signal, hey, what is your MAC address? And then your computer will send a signal back saying, this is the MAC address. Like, here is my MAC address. And then the switch, if it is also a switch, if it's also a router, then we would go up a layer and work with IP and say, who has this IP address? And that functions a little bit differently. We're going to talk about that in a second. So is anyone unclear, I guess, at this point, of what a switch would do? And some examples would be, maybe you want to connect to your printer. Maybe I want to send like maybe I want to print a page. So I've got like a printer over here. Imagine I want to print a page to my printer. If I do that, I have to send a signal from my computer over there to my switch, which will then connect my printer and say, okay, Anthony's computer is trying to send a page to you. And it does that via your MAC address as the connection. Is Cisco considered big tech, CI? Yeah. I mean, it's a different kind of big tech, but yeah. It's infrastructure. Now, all of these central nodes, they all connect by a certain type of network topology. Typically, everything's going to be a star network. So that's where that comes into play here. So if I had switch star network, here's an idea of what it would actually physically look like. All of your endpoints have a Ethernet connection to a switch, and the switch just routes connections back to one another, and it uses a source MAC address to destination MAC address, which we talked about, is essentially like your physical address. That might be stamped physically on the computer, on the motherboard, on the network adapter, or it might just be something written in code. But you can only have one MAC address and one IP address to make this work. Is that clear? Let me know. Give me a thumbs up or something. Let me know, let me know if you're tracking over there. Is anyone unclear on what these devices are? If you're just kind of lurking, chilling around, that's totally cool. I'll kind of pause there for a second. Okay. No. Yes, yeah, okay, cool. Karina, yeah, so in the middle of the picture, yes, that is the switch. And if it helps to make more sense mentally, the switch is switching connections from one endpoint to another. The router is routing connections from one network to another. Cass is lurking today. That's all good, guys. Lurk away. Cap. Yeah. You thought I was about to say no? Like, that's not a switch? Yeah, yeah. You got it. Good job. You're following. And what you're seeing in front of you is a star network. Yes, Karina, like a switch operator back in the day. So yes, you would have like these switch operators where they would like, I'm going to take this connection and I'm going to put it here, and this connection, I'm going to put it there, and back and forth. Like, that's what switch operators were doing. Like, oh, you want to talk to so-and-so? Let me take your connection and let me put you on that side, and so forth. Yes, that's like what switch operators do. That is what a switch does, but with virtual, like digital connections. Yep, that's how that works. Maybe 1940s, 50s, yeah. Yeah. Cool. Alrighty. I think we'll take like a little fiver right there. I'm gonna grab a cup of tea. And then we're gonna come back and we're gonna look at IP and subnetting. That one's gonna be a little bit complicated. I apologize in advance. It is never easy the first time you try to understand IP addressing and subnetting. I'll try to make it as painless as possible to get the message across, but that one's going to be hard. And transparent point, I mean, I don't subnet. I don't need to subnet. I generally forget how to subnet because I don't need it. But I understand and can recall and say, okay, yeah, I gotta remember there's like these rules and stuff. Just like this stuff that we're looking at right now, I am not sitting here like configuring optimal routes. I'm not a network engineer. It's not my day job. If it was, I would just have to like go and study it more and figure that all out. This is why in IT and cybersecurity it's such a broad field, because everything I'm showing you right now is effectively an entirely different position. That is going to becoming like a network. That's becoming like a network analyst, and then a network engineer, and a network architect, and so forth. So what's most important is you shouldn't be trying to master this stuff. I will tell you what you need to know, like most importantly as we go along, but you need to generally conceptually understand how these things are functioning. And over time, you will get better at the things that you need to know based on your goals. So for those of you, as we go through this and you're like, this is really cool, like I want to become a network engineer, then I tell you, fantastic, continue learning, going through this course, and then at some point you should go and start studying like your Cisco, like your CCNA, go that route and learn how to configure these devices, because that's a whole different field. All what you need to understand is how endpoints are connecting to one another on a network. That's it. So let's summarize that. Endpoint's your PC. Node is some type of device that sits between your endpoints to connect them together and do things with the connection. A router is a node, and it routes your connection to other networks that contain other nodes and other endpoints. The switch is a node that sits inside of your network, and it switches connections from one endpoint to another endpoint inside of the same network. Does that make sense as a summary? Yeah, FinAC, learning subnetting for the first time was painful. It's never easy. Cool. Okay. I'm gonna go make a cup of tea. I'll be back in like 5. This will be a shorter break. I think there will be an ad that should play. I think. Not sure. Still learning this Twitch affiliate stuff. But yeah, I'll be back in 5. You should all go stretch your legs as well too. Go get a cup of tea. And we're going to dive into probably, I guess probably the hardest part of the ball. Karina, that was a nice summary. You know what I'll do then, before I go? Just actually write that out. So to summarize all of this, kind of once more. No space. Routes, connections. You hate that when you run out of space. I write to the edge. Routes, connections from one network of nodes and endpoints. Uh-oh. To another network. Okay. Switch. Switches. Connections. from one endpoint or node to another on the same network. Okay. Bit highlighting here. Routers and switches are nodes. PCs, endpoints. Why are they called endpoints? Because they're the end of the connection. Draw them as you might have it that once more, I know we're spending a little bit of time on this, but it's really important stuff. Clicks. Cool. Yes. Yes, Stephen. The switch just lives strictly on the local area network, yes. Can it reach out to the internet, or is that not possible? It can. You might have like smart switches that have layer 3 functionality, but to get out onto the internet, you need an IP address. MAC addresses are for like local area network routing. And we're gonna dive into that shortly, actually, here with IP and MAC. So I'm gonna go make a little cup of tea that helps me talk, and I'm gonna be right back. Gonna leave that up, but good question. And yeah, Karina, yes, grateful spending the time. This stuff is so important, like conceptually, to understand. The rest of it is very practical. Like there's a lot more labs, but you don't have like a switch in front of you. You don't have a router in front of you. So I need to spend a little bit more time, and you can't touch and like feel IP addresses and all this stuff and DNS. So we have to talk about it quite a bit. and then we can get into the more fun hands-on stuff. If we were inside of like a server room together, and we were in like a live classroom, and we had switches and routers and cables and stuff, yeah, I think that would be a little bit easier to do. Twitch is auto-adjusting you. Yeah, Finac, Packet Tracer is amazing for this. So the network module is really big, and we want to stay on track to getting you to like IT help desk kind of level, and then SOC Analyst right after. Maybe in March onwards, or maybe once we, I might do some separate streams later of just like deeper networking things. Like, let's load up Packet Tracer together. Let's configure a switch together. Let's configure a router together. It's not in the course. Those might just be separate, like non-SOC 100 streams, but I would love to do them because I think it just really makes all this make much more sense. That'd be really cool, actually. Okay. Break time. I'll be back. Yeah, showing how they flow. Well, Finac, I mean, we're going to use Wireshark, so we're going to get a visualization to show actually how this stuff works. Like, we're going to be looking at protocols soon. But yeah, I think actually showing you how to configure like a VLAN and then doing some packet analysis out of Packet Tracer, stuff like that. Super, super helpful. Zeno, yeah, definitely would be great. Cool. Okay. Let's go take a little break. Now, I think if you are a sub and ad plays, I don't know, but if not, I think the ad will just play. DT, we could do this on podcasts. Yeah, that'd be super cool. We should do like a live, like, we should have maybe some like study material and then do like a live like workshop podcast kind of thing. Yeah. NetFlow and networking is super cool. Like, the more you get into it, there's so much cool stuff that you could do with it. I love it. Alrighty. We're back. All right. Are back in action. Cool. I was thinking about what you were saying, DT, when I was grabbing a cup. And I like that idea, like practical podcasts. I think that'd be really cool. Like little exercises to do. That is also, like, it'll function as a podcast you can listen to and kind of learn as you go, but then also practical with something that you can do. We had the Facking Friday series that was kind of like that, but I kind of like the notion of the practical podcast. I'll come back to that idea. That's right, man. Got a ton of ideas. I like it. Karina, what drawing software am I using today? I am using something called Element Note, which I think it's pretty good. I like it so far. It has this ability to, like, if I have my pencil down and I kind of like hold, I can also do like other stuff. I haven't really gotten fully used to it yet, but element note, it's got a lot of different types of... It's good just for like notes and visualizations and drawings. It's not noisy. I find the other ones get really, really complicated. So element note. I should put that inside chat. Try that out. Steven, it's saying, you're saying it's great to dive deep in these topics, start really understanding how everything works. Yeah. When you were a young mechanic, an old timer once told me that to confidently diagnose anything, first you understand how everything in a car works. Yep. Yep. That's it. That's just how it is. And honestly, if you're in IT or inside of cybersecurity, you're essentially a computer mechanic. That's effectively what your base job is. A computer mechanic. Now, you might be like a hardware mechanic, like certain parts of the car, certain parts of the engine you might specialize in, but you do need to understand generally at least how everything does work and why. Cool, cool, cool. Okay. Let's jump into some of the more interesting... I mean, this is all interesting, but let's jump into some more of the complex stuff, I should say. We're going to dive into IP addressing and subnetting. Can you add computer mechanic to your LinkedIn? You can add SOC Analyst Tier 1. When you're done SOC 100-1, you should definitely be able to advertise yourself as a help desk analyst, maybe like a systems analyst, IT analyst. Yeah, you should definitely be able to advertise yourself as that. From just SOC 100-1. When you get through the entire course, you should... The goal is, by March, we will have you triaging Tier 1 Cybersecurity Analyst tickets inside of a virtual SOC, a Virtual Security Operations Center. You will be triaging, like, the basic stuff. Like malicious IPs, malicious domains, malicious emails. You should be able to do that by the end of this. Like, you should be able to feel confident that you can go to an interview and walk them through how to triage Tier 1 types of Cybersecurity Analyst tickets. That's the goal. And I think you can see by how much, like how deep this goes. This is not like in a high-level PowerPoint type of course. We covered a lot Windows and Linux, and we're going to get really deep. You will do malware analysis with us soon in the next couple courses. Cap City, subnetting, you don't feel enough coffee. Tell me about it. This is... Subnetting is the thing that you'll hear. So all of you that are new and following along and on stream or on recording, subnetting is... It's the thing that everyone remembers of like, oh, I really didn't like to like learn that. Now, some of you might like pain. And you might be masochists, and you might just be like, this is amazing. I like the hardest difficulty on everything in life. You might enjoy subnetting. That's for you. We've all got our interests. But it's a thing that everyone remembers. And Hades, good to have you. It's all good, you're late. All good. Good to have you back. But this one is where it gets a little bit more complex. From here on out. Okay, so let's go and walk through this together. Let's talk about subnetting and IP addressing. Okay. Oh, cool. That's awesome, R double. Thanks, I appreciate that. It'll be great to have you with us. And the live cohort is a lot like this. You have a lot of like instructor kind of working with you and such with the live classes. Stay tuned for Tuesday. Stay tuned for Tuesday. Might be doing some special sales. CIDR live for Black Friday. Our first time we can actually do sales now on our new platform, so stay tuned. Okay. All right. Let's do this. Let's just rip off the Band-Aid. Let's see if we can find like a nice visual first. And we're going to talk about it. Yep, we're going there. We just so you know, we're going to this type of you see that in the stream, right? We are going to that. It's gonna get there. I'm just trying to find like this like a decent one, and then we'll kind of walk through together. Okay, I think this one was okay. All right. So as we mentioned, we have this notion of an IP address, and an IP address is effectively a 32-bit address. And remember that a bit is either a 0 or a 1 in value. It is a binary value of that signal kind of going 0 and 1, high and low. And that binary representation let's see if we can find a better picture for that. Kind of want to count up. Oh, I think this is good actually, right? Yeah. Open image, new tab. It's really blurry though, this one. Cool. Yeah, there we go. All right. Because there is no way I'm going to write that out. I am not about to write this out for all of you or myself. I will develop carpal tunnel by the end of that. That's like punishment in school, writing on the chalkboard. All right. So, binary value is represented by that digital signal of zeros and ones that we just talked about, and then that we've been talking about over these past few streams. And if the value, or if the signal is all 0, like all low, it's interpreted as the decimal value of 0. And that's what your computer does. It takes those signals, and it same thing like a modem, and so it modulates and demodulates. Very similar. And this binary value will increase in terms of like 0, 1, 1, 0, 1, 1. It counts up. Remember, there's only 2 possible states that it can be in. It's 0 or 1. And then that's just interpreted. So it's just interpreting the combinations of zeros and ones. And each unique combination is then represented by a decimal value. So when I say that we have 8 bits, that means we have 8 positions of 0 or 1 that can all be toggled on to a point that we get from like 0, 0, 0 all the way to fully ones across the board, or a combination in between, and that turns into a decimal value that we understand. If we have 8 bits, then the maximum, it's probably even better to look at. What is this image? Okay. It's fine. That's not fine. That's a terrible image. I just want like a good binary decimal chart. I swear I had one before. Binary to decimal chart. This is why I just end up making notes as I go. I'm trying to find an image that just shows you from like 0 to 255. That's it. Okay, we're just going to work with this. So, eight bits, the maximum that it can be, if you add up all the combinations, from 0 to 255 is the maximum allotment of space that you can get for 8 bits. So this image, thank you, this actually shows it over here. If I look at this image right here, you can see that that 255 representation is the representation of a binary value of all set to 1, and the position is 8 bits. And we say that the IP address is 32 bits because each they're called octets. An octet is 8 bits. An IP address is 4 octets. 4 times 8 is 32. So that's why we have a 32-bit address. Now, each octet is maximum of a value from 0 to 255. So that's to say, if we had an IP address of, say, maybe like 192.168.100.10 as per this image, the first octet, the reason why that's even 192 is because the first 2 bits are set to 1, and they kind of scale up in that possible chart that we looked at over here. They kind of just keep scaling up in value. Now, you don't need to memorize that, so you can go to like a binary to decimal converter. Totally fine. No one's remembering this stuff. But if I were to do something like 0, 0, 1, 2, 3, 4, 5, 6, convert, you can see that this is representative to 192. If I were to do 8 of them, that's representative 0. This is representative 2. Whoops. And so forth. And so forth. So they have positional values. SolarWinds Advanced Calculator. Nice. Okay, cool. Yeah, this is nice. Ooh. It's even got little calculations on it for me to do. That. Nice. This is actually pretty cool. Thanks to EDU. This is going to be helpful. Fantastic. So, yes, a forewarning. No one remembers this stuff in their head. No one is remembering all the different types of subnets and possible values and ways to calculate IP addresses. We have a general idea, and that's good enough. Now, if your day job is working inside of network engineering and such, you'll just be so much more exposed to this stuff that you're going to remember like quick ways and mental math, kind of like how we learned the times table. Remember in school? The times table? 1 times 1, 1 times 2, 1 times 3. You learned that times table to be able to perform the mental math faster. If you didn't learn a times table, that would suck. But you have a table to look at, to reference, and you can only remember so much until you need a calculator. IP addressing and subnetting is exactly the same. Exactly the same. So to kind of look back at this, the IP address is a 32-bit address, and that is given to us on the network. There is a device on the network that provides IP addresses. Now, this is called DHCP. This is called Dynamic Host Configuration Protocol. It is a system for assigning Internet Protocol addresses to each network device known as a host or an endpoint. And what it kind of looks like is it could be a server. It could be built inside of your ISP modem or your switch or your router. Like anywhere along there could have the functionality of acting as a DHCP server. And as you can see in this diagram, we effectively have this server that hands out IP addresses on the network and manages it for us. So I hope that's a relief, that you do not have to be manually doing this stuff, and that this is automatically managed by a DHCP server. Now, all what we have to do is plug in some initial requirements of how we want to construct our network, and we're going to talk about that. That's subnetting. And then the DHCP server will do the rest of it for us. And remember, we're talking about the OSI model for sending connections back and forth to one another. A switch doesn't care about IP addresses, it only cares about MAC addresses, because it's faster. There's less hardware, less requirements. An IP address goes up one layer to layer 3. It requires a DHCP server. It requires additional configuration. It requires IP address management. Remember that it's a 32-bit address, meaning that there is a limited functionality a limited scope. There are only so many IP addresses to go around. So it starts to create more complexity, more requirements, more management. Routers get involved at the IP address level, as we talked about. So if we had this diagram in front of us, where the top computer wanted to connect to the second computer, so 192, let me zoom in. If we had 192.168.0.22 that wanted to send data to 192.168.0.13, it's going to first see if there is a switch connection and the MAC address is available. And if not, or if your network is configured to send connections by IP address, if you prefer that, you could, then it'll go up a layer to IP addressing. Now, for the most part, your network is going to be switch-based. It is faster. MAC address connections back and forth is significantly faster and easier to manage. But at the human level, and as we go up, right, to DNS, IP addressing becomes more and more important, resolving domains. If I wanted to go to google.com, my computer, if it was, say, the top one here of 192.168.0.22, it would connect to my router, perform the DNS lookup beyond the network. It would do all of those DNS server lookups and find the A record, which would provide the IP address. It would then come back into my network and then be sent back to my computer. And I would connect by the IP address at that point. And remember, IP addresses, routers, is connections beyond your network. Subnetting is that exact process, but it is a network within a network. And it doesn't have to go outside. It doesn't have to connect to your ISP. And I'll give you a more normal example after that I always think makes more sense in my head. So let's take a look at this example. Here we can see on this image, the internet, with all the servers and everything, has that router in the middle, right? Like there are these routers outside in the internet that's moving things all around. Now, your ISP, your home modem, could be that router in the middle. And what it could do, if you wanted to have maybe you wanted upstairs and downstairs in the basement to all be in different networks that didn't talk to one another. And if you were at work, maybe you wanted accounting on a different network. Maybe you wanted HR on a different network. Maybe you wanted engineering on a different network. This is where subnetting comes into play. But it functions the same way, going up to layer 3 by IP address connections. Subnetting creates a small network within another network. Now, if that's not making sense, and it probably really won't make a lot of sense, because it's just how it is, I like to consider more, think about this more like logically, with non-computer stuff. So imagine that I had, this giant warehouse. Okay. Or a shop, it doesn't really matter. Here's the entrance. And let's say I had, like, this is all space that I could use, right? I could fill up this warehouse with stuff. Now imagine if I just started to like fill up this warehouse with like boxes everywhere. I just kind of like put them all over the place. Boxes over here, boxes over there. And let's say like I needed to get to like box F or something. There's like boxes everywhere, like it just like covered in things. It would be pretty complicated for me to walk in and try to like maybe find my way and snake around this stuff. For me to get over to like this destination. So what subnetting is effectively trying to accomplish is structuring the amount of space that you have into organized areas. And what you would want to do instead maybe is go to like this central room, which is your router, and you could very easily and quickly get to the destination that you needed to go, and you could organize your space and always be able to find it. That's what subnetting is actually primarily for. It's just to logically separate your space so that it doesn't turn into a disaster. And you could walk into a centralized area, which is this node that I'm circling like crazy right here. That's your router. And if I wanted to go to network F or network E, G, M, it doesn't matter. Subnetting is trying to organize your network space into logically organized areas that you can have smaller scope and control and get connections in and out faster, and also provide segmentation. Maybe I wanted to put like books. Maybe I wanted to put clothing. I don't want my books covered in my clothes. So I want to put them in a different area. So maybe I want to go and put all my books in the G subnet. So I'll walk in. If I wanted to get there, I'll walk and I'll say, hey, router, where is the G subnet? I want to find all my books. It'll just be like, okay, it's cool. Just go northwest, like go up there. It's in that section. Perfect, done. And now if I said, oh, wait a minute, there's some clothing over here inside the books area. I need to go and send it actually to the proper place, or I have something I need to bring back and forth. And if I'm over here inside of G, I'll just go back to the router and say, okay, where's clothing? Routers will be like, yep, you want to go straight over to F. Cool, good. So bro's saying subnetting is just like my first retail job? Yeah. Yes. Exactly. It's just like working in a warehouse, working in a library. Imagine stocking books in different sections in a library. Same thing. You got the romance section. You have the history section, you have the fiction section. They're all split up in shelves. And they're all made up of shelves of books. You see, like, they're all books, right? Like, they're all the same thing. And these networks are made up of these endpoints same way. Just change books to PCs. Yeah, okay, yes. Oh, I wish I had, like, a soundboard for that one. Yes, we have the networking section of books. Nice. Well done. Well Yes. This is why we subnet. Good stuff, Karina. I got someone to say right away. Bro jumping in there with a warehouse at Target. For someone to understand right away why we subnet, that is like, that's a personal award. That feels good. It is. This is what subnetting is at a high level and why we do it. We want separation, segmentation, and we want control of the amount of space that we have. So, what does it actually look like? Well, it looks like this image now. Now imagine you came in from the internet, which is the outside, and you walked inside of that warehouse, and you needed to get to a certain shelf or box. The router would tell you where to go. Yeah, nice. Yeah, same thing. You have to scan every item and shelf it went to. Same kind of thing, right? Yeah, like you're going to do asset management, and you're going to put the right connections, the right items in the right shelves. Maybe you have to go and move the HR book and put it into another shelf. Maybe you have to go take that networking book and put it into another shelf. And then you have to update your records. You're doing the exact same thing, but with computers. Drop HR from tables. Nice. Yes. You guys are on fire today. AS and Bro, and in the lead for networking jokes and code jokes. Perfect. Cool. Okay. So that's fantastic. Like, we're making real good progress then to understand it like this. So now we need to actually break this out a little bit more and get into the nitty-gritty and talk about this representation of how these things are functioning. So remember, we talked about DHCP. And the router or the switch. Second. Cool, let me just sorry about that. Just gonna gotta mute all my my things. But I see a message on the side. Cool. Yes, so let's talk about this whole process now. Let's kind of walk through it together, make sure that we get a high level understanding. Yeah, bro. Yeah, sorry, you guys could hear that. I need to like mute Discord entirely. I thought I turned off notifications for Discord. I should be on Do Not Disturb. Oh, that's why. My Windows clock said it needed an update. Thanks. Thanks, Microsoft. So my Do Not Disturb, it didn't go on because my clock needed an update in Windows. Wow. Yeah, everyone's checking their Discord when they hear that. Yeah, sorry, guys. Friggin' Windows. Microsoft. You just disabled my Do Not Disturb ability because my Windows clock needed an update. Okay, anyways. Enough of that. Yeah, right? Imagine the domain controller needed an update. It's like, oh, I'm just not going to provide a domain to everyone. All right. Well, let's connect this all together now, everyone. Let's walk through this process and see how this actually is all functioning. So now we understand conceptually what is happening. Let's actually go through this DHCP kind of provisioning process. We're going to go back to that star network. And this central node, remember, this is like your router or your switch. It is also possibly a DHCP server too. Very likely at home, it is your DHCP server. I'm gonna say like not it will be, unless you've done anything differently. Your ISP modem that you have from your internet provider will also have DHCP functionality, which hands out IP addresses. And by default, your base network is probably going to look like something like this: 192.168.2.0 or something like that. Is going to be like your base network. And that's going to be configured by your internet provider, and by default it's going to be something like that. Now, your DHCP server has to then say, well, what IP address am I going to hand out to people? And it's just going to do this very logically. It's going to say, you are .1 and you are .2. But you're part of a certain network. There is a certain portion of the IP address that is considered to be your network ID. And then you have your host ID. This is how DHCP is working. It says, okay, it says, if this is my network of 192.168.2.0, then, yeah, see, private. We're going to get to private and public address and stuff soon. So 192.168.2 is the network portion of the IP address, in this case. And then I have from 0, from dot, sorry, I should say not like that actually. I have from .1 to .255 of usable space, which, not entirely, but for now, yes. Okay? We're going to talk about there are certain host IDs or host values that are reserved. But for all intents and purposes, this is the amount of space I have. And remember, that's that binary representation. Is equal to 255. So that's my limit. Because remember, it's an octet, 8 bits. The value is either all the way 0 or combinations of zeros and ones. And it can only be from 0 to 255. That's my space. I can support 255 addresses effectively at that point. So what your address, your actual IP address looks like is 192.168.2.1. That's like your network portion. Host. 192.168.2.2. And again, this is your network portion and then your host. Write that out. Just gonna write. You know what? Second. Forget that I have a eraser. So this DHCP server says, okay, well, I'm configured to work with a single network, a single LAN of 192.168.2.0, and I now have 255 addresses I can send out. So I'm just going to do it. I'm just going to like, okay, you connected. Cool. You're .1. Another connection. You're .2. Cool. Another one. You're .3, .4, .5. Nice. Easy. That's all what it does. That's all what DHCP does. And it manages that for you. So going back to this image, let's take a look at that again. This probably makes a little bit more sense now if we kind of talk about this. Yeah, 0 is false and 1 is true. But it's, in this case, we're talking about 0 and 1 being a value, not false and true. So the network portion, you can see it in this type of address. The network portion is those first 3 octets, and the last portion is the host portion, the host bits. So we have network bits and we have host bits. This is probably the simplest it's going to be. You have one possible network space. This is the equivalent of walking into the library or the warehouse and just being like, okay, I'm just going to use that entire space and just individually put everything as just like one book here, one book there, one book. It's like one giant shelf, one giant box, and you just put everything in there in an orderly fashion. That's like your base network. That's what your ISP does, and it has a DHCP server that manages that for you and puts them all with an assigned label. CI, so no, the host is not always after last decimal, and that's where we're going to go. So that's all well and good. But then we introduce this notion of subnetting. We can now turn a network into 2 networks. Remember we talked about that. We're going to take that space and we're going to change the shelf, or change the location of how these shelves are organized. So this is the equivalent now of going back in that warehouse, just chopping it right in half. If maybe we wanted to have 2 networks inside here, we're going to have subnet A and subnet B. And we're just going to have this router that connects to both. And then inside of here, we're going to have a switch with endpoints that do their own thing. So this is now how we've created subnets. Now, subnetting, the way that this is accomplished is by grasping that binary type of understanding of things. So before we jump into that, we need to determine how large, like, is subnet A large network or a small network? What about subnet B? Is this a large network or a small network? If we were to just take our base network and give, let's just say we did something like 192.168.1.0, and this is 192.168.2.0. We can see over here that there's your network. That's like your starting points of the network. We have a maximum space of two different networks that could then become 192.168.1 all the way to 255, and then 192.168.2 all the way to 255. So we could say each of these subnets now can support 255 endpoints or hosts. Still following so far? Gonna pause there. We're gonna start getting a little bit deeper. Yeah, Senpai. Yeah, we're just about to get into class A, B, and C networks, and yeah, just about to get into CIDR notation and subnet mask and stuff, so leading there, almost there. Arena feels good, cool. So conceptually, again, we've now moved from this warehouse analogy, and we've now moved to working with values, like these subnets, and binary representation into IP addresses. Cool. So still making sense. So we have this notion now of a subnet mask. Okay. And the mask is just to let us know how much of that 32-bit address is reserved for the network address. That's typically when people say, what? Typically when that happens. No comments yet? Okay. All right. Okay. So the subnet mask is it's a representation, like decimal, right? 255, 255, 255. We look at the decimal value of that. But the mask level is just trying to figure out how many of the bits are set from left to right, counting all the way up like zeros to ones. In this case, if we were to say we use the first three octets, to preserve the, like that's used for network ID, then that means 24 bits are set to 1. And that's why you see like the first three octets are all 1, the second octet is all 1 in this image. And then that decimal representation is 255. This allows us to know that we have the final 8 bits of host space, which again, if you count from 0 all the way up, is another 255. So, for all intents and purposes, again, the subnet mask is just to separate how many bits are representative of the network ID and how many bits are representative of how many host bits we have, or host space. This is a computer thing. The computer needs to know this. Remember, zeros and ones. So the computer is looking at this, and that's how it's actually reading the network portion. So the computer looks at the 192, if we look at this image, the computer looks at 192.168.100, and it only understands that that is the network portion because the subnet mask says that those first 3 octets are fully reserved for the network ID. And then the computer says, okay, anything after that, that 4th octet of 0 to 255, are hosts. Those are computers. Those are your phones. Those are your consoles, etc. That's how your computer understands that. And then we as humans look at that value, and we may need to say, okay, subnet mask 255. We do that as a quick like visual when we're troubleshooting. and we have two endpoints that aren't talking to one another, an easy way to look at that is, does the subnet mask match? And therefore, does the network ID match? And we're going to get into something called CIDR notation very shortly to make that even easier for us. But that's why the subnet mask exists, because I can tell you that we've chopped up that portion, the top over there, of the network, like that is the network ID. I should rather just say like network address. I can tell you that. But the reason why the computer understands that is because the subnet mask is stating the first entire 3 octets is the network address itself. Does that make sense? Is anyone unclear on that? Stephen, yeah, damn. Okay, so mostly following along. Some yes, some no. This one's hard. This is going to be like the most complex thing. Okay, thumbs up from Karina. All right. Steven's brain blew. It's all good. All good. Okay, cool. You're good too. All right, good. Still following. So again, this is all well and good when we're dealing with this type of network of the first 3 octets entirely being 255.255.255. That's all well and good. The complexity now starts to happen when we want to determine, well, what if I want 1,000 hosts? What if I want 4 networks of like 30-ish hosts inside each one? That's where things get a little bit more complicated now. And this is why we get into this notion of subnetting. We now have to start performing what is effectively math. The only thing that the computer understands is binary, and you have to perform binary math at this point to determine your desired subnet. Yep, bro. And this is why. So let's actually do this now, right? We can probably start with just this basic one, 192.168.1.1, sure. Mask bits. So the first 3 octets, 24. Here's a subnet mask. This is saying, and you can see this is exactly kind of what I Gotcha. Okay. That calculator was throwing me off for a little bit. I was like, what? I didn't make a /25. I haven't used this one before. I see. Okay, cool. All right. This is actually going to work really well then. Sweet. TT. Oh, I think bro and KS, there's a contender here for the networking jokes. DT just went up a rank. Apple cider. Nice. Okay. All right. So, if we look at this chart right in front of us right now, if I were to say I had a subnet mask of 255.255.255.255, that's like saying 111, like one away across the board, all used. Therefore, I have 24 out of the 32 binary bits used. So, important number, 24 bits. That means that we have this thing called CIDR. CIDR notation. Now, this is in CIDR, we actually represent networks by a slash to make this easier so we don't have to look at all the mask bits for us. This is why we have this thing called a /24 network. We're using CIDR notation, and this stands for classless inter-domain routing, I believe. Yes, classless inter-domain routing. CIDR notation. Okay. Because we are using 24 out of the 32 bits for network address space, we now have a /24 network. And that means we have 8 bits left for hosts. And if you look at how this calculator is kind of doing in front of you to show you, here are the first 24 bits entirely taken up, and then we have the final bits left over. That means that the start address is going to be .1 all the way to .254. Now why? And this is why I want to pause here. There are reserved spaces. Your network address is an address. It's an IP address of its own. When we walked into that warehouse and we wanted to get to a different shelf, those are organized not like shelf A and shelf B. That is organized as network address 192.168.1.0, and the other one is 192.168.2.0 in this case, or it could be something like that. But it starts at the beginning of that host space. So the first possible value is 0. And then we start at 1. We actually go all the way to 254. And we do that because there's another reserved space called the broadcast address. And the broadcast address is a special address. The broadcast address is used. Do you remember when we were going back over the process flows? And we said, hey, who has this IP address? We use the broadcast address to figure that out. Because it goes up the stack, and we're trying to figure out like how to get to a certain IP address. And we don't necessarily know that. And it kind of works like we're trying to find out who has the MAC address, who has the IP address. We're actually going to broadcast everything on a certain address space. I'm going to make sure everyone's kind of following that for now. I might take a pause right here. You're good, okay. Okay. So there are certain reserved addresses inside of an address space of hosts. Remember, we can have, in this case, there are 8 bits. Therefore, it can be from 0 to 255. The .0 is part of that is used in this case for your network address. That's the subnet. That's your network subnet. The .1 is the first usable space. And sometimes that's reserved for things, but that's the first usable space. And then we have a certain address at the end of it, the highest it can ever go. So in this case, .255. This is something called the broadcast address. So the broadcast address is used effectively. We are trying to map an IP address to a MAC address. We don't know what that is. We're effectively like saying one computer says, hey, yeah, so is it like saying, yes, just pretend that 0 or the first possible address of your host space you can't use. That is part of your network address. You can't use that. So we now use this final space, .255, the last host address space, when we're trying to speak to one another inside of a local area network. Remember, a switch works at layer 2 with MAC addresses. Now, my computer doesn't necessarily know the MAC address of another computer and network. It stores that information temporarily. And this is now a protocol called ARP. This is called Address Resolution Protocol. That's okay. Like how that shows rifles. Address Resolution Protocol. ARP. Okay. So, where was my tab? Too many tabs. Here. Yes, more protocols. Everything is based on a protocol. Here's actually a good image. So here we have the first host, and it says, I want the MAC address of 10.00.2. It's going to broadcast that. That's a message that will be broadcasted on the entire network, but not by you. So remember, in the middle we have a switch. Switch does all the switching. It does that at a MAC address level. Your computer doesn't connect to other computers that way. It'll send that information to a switch. Now, your computer says, I need the MAC address of another host. So your computer actually tries to reference these other devices typically by their IP address, because that's easier to manage. And it's easier to manage for us. And that's an important thing to pay attention to. So we have decided and we have determined that it's easier for us to work with like 192.168.1.0.1.2.3. So we program that information in and we tell our computer, if we actually now want to get from computer to computer in the network, we are going to ask by IP address, what is the MAC address to get there? Because the switch uses the MAC address to route. I shouldn't say that's going to confuse you. The switch uses the MAC address to switch connections. So the broadcast address is a special IP address that we will shout out to. The switch just says, hey, who here has this MAC address? And it's going to broadcast on .255 in this case. And it's going to actually message everyone on the network at once. That's actually how it happens. It's really noisy. So host A says, hey, I want the MAC address of 10.00.2. Switch says, it's got to be a better image of that. I'm gonna have to draw it. Okay, yeah, here. This is better. This is better. Okay, so computer A says, hey, we will be able to see it in Wireshark. Yes, we're actually going to be doing ARP inside of Wireshark. So let's take a look at this little image. And computer A says, hey, what's the MAC address of 10.0.0.5? The switch says, I don't know. That's literally what happens. Now the switch might have it stored, but in this case, if it doesn't, and it doesn't, it's going to happen actually pretty often. It happens like every several minutes inside of a network. Because remember, the switch is a layer 2 device. It doesn't really store this information. IP addresses can change, and they change a lot. The switch broadcasts out on the broadcast address, and it's going to message computer A, computer B, C, and D, and say, hey, who of you has this MAC address? Every single computer will get that connection. And your computer reads it and says, wait a minute, I'm 10.0.0.5. You're trying to get a hold of me. Hey, switch, here's my MAC address. Switch takes it. It's cool. And then sends the MAC address back to computer A. Now, you now have the MAC address. And when you do LAN, like local area network connections, your computer's good. It doesn't have to do this anymore. It'll package up things and send it by MAC address and speed this whole process up to make it nice and fast. That is ARP. That is Address Resolution Protocol happening in action. So this is going to happen quite often, and this is part of having operations inside of a single subnet. But again, like I said, that's all well and good, but you can see the problem here. If we run out of hosts, if computer A says, I actually want to talk to 192.168.2.15, that's a different network. Now we need a router. Now we need a router involved. And now we start to do subnetting. Senpai, yeah. Cool moon. Yeah, this gets like, so for those of you, like I said, that want to get specialized further in network engineering and architecture, this is just the tip of the iceberg. I am not going to go, like, Broadcast Storm would be really cool to look into. There is so much more that is actually even happening. Way more. And eventually, you know, like, you're going to pick up pieces that you need to understand and as you move around. But these are the most important pieces for now. So, go back to this. We're now back at this, like, single IP address. And like I said, there are special spaces. So, if we want to create... Yeah, you get the overall idea. Yeah, for sure. And you don't... Once we get through this, you really won't need to be subnetting that often. It'll kind of come up dependent on where you go. But just generally understand the structure. That's what we're aiming for. So, we now have certain address spaces. I think that's... Oh, that's the actual video. I thought that was an image. 1 second. I want just the image. Open image in new tab? Oh, yeah. All right. Let's go and take a look at this now. Great. Yeah, like I said, the networking area is the chunkiest. Like, a lot of this is like theory, and you have to listen to it again and make more sense of it. It's okay. The labs are going to start helping to stick a little bit more. As we're almost there. We're almost there. So we're going to take a short break after this, but I just wanted to introduce that there is now a certain address space that we need to contact out to. And we can start doing some summaries of this stuff. This is not what I'm looking for at all. Cool. Okay. I think this is a better one. All right. So we actually have, this is defined by national organizations. We actually have several different types of address spaces for private local area networks. This is an industry standard. So our private address space can be considered either class A, B, or C networks. And a lot of this is going to depend, a lot of this is going to depend on effectively like how big your company is. If you have a lot of endpoints, you're just going to use larger address private spaces. Just keep that in mind. That's all we need to know. Like class A is the biggest, class B is the middle ground, class C is the smallest one of them all. And this is why you might see, like, a lot of times, actually the past, like, several classes, I've always been saying, like, 192.168 dot something. That's why. Like, this is an industry standard of, like, a class C address space. You might also see 172.16, and you might also see 10.0.0 something. So, effectively, you're going to fall within that category. The most important thing to understand at this point, before we get even more into it, is that these are private addresses that do not route online. Like if I were to go to my browser and if I wanted to type in like 10.0.0.0, or rather 0.5. You can see it's just going to hang up. But if I did like DNS, before we get to the command line, DNS lookup, google.com. Okay. This is a public address. This is doing a DNS lookup for me right now. If I went inside here and open up a new tab, I'm actually going to get to Google because this is a public IP address. Private IP addresses within these ranges of class A, B, and C networks, you cannot connect, like those are not addresses to connect to out online. Those are only subnet addresses. That's important to remember. Class A, B, and C are private IP addresses for only inside of a subnet. So if I were to go back to the good old iPad here, this is effectively like saying this is a class C. Because it falls within that 192.168.0.0 range. So your DHCP server needs to be configured. Yeah, it's all going to be org dependent. All these address spaces are going to determine is the size of your network space. And all what it's going to do is just be an adjustment of network bits and host bits, kind of moving it along and using something like that calculator that we saw. So if we went back over here and I said I wanted let's say I wanted to increase like my mask bits, like my network bits, then that means I'm actually running out of host bits. So it starts to, I'm getting limited in scope. Or I should do like this. Weird calculator. I'm gonna play with that a little bit more. I think it's gonna confuse students a little bit too advanced at the moment. If I were to just like toggle this calculator back and forth, depending on what I want to do. Oh, okay, I think I see how this thing's actually functioning now. Okay, it's a separate thing. All right, sorry. All right. So as you can see, that little like green meter fills up. Well, there's only so much space I have. If I'm setting that I have 24 bits for my network address, then I only have 8 bits left to mess around with creating individual subnets. So if I wanted 2 subnets out of like a normal address space like this, out of a /24 network, then I would start at .1, I would go to .126, and then my network address is .0, my broadcast address is the last usable space, but then I have another subnet, and it actually is going to be starting at 129, and then going to 254, and the network address again starts in the beginning. And I think I'm actually going to walk through that manually with you, because I think the calculator is just going to throw you off right now. So we'll take a break there. And then we'll come back and try to summarize some of this and demonstrate it in action. So Karina's saying, so private address network and subnet are kind of the same? No. A subnet is made up. A subnet has to use. Let me try to connect those two together for you. A network is made out of private addresses, like a private address space. A subnet carves up that private address space into further individual private addresses, kind of like cutting up a pizza. So if we had a pizza and we carved it, we kind of cut it into 8. Then you have 8 slices. That would be like 8 subnets. And inside of those subnets are private addresses. And the entire pizza is where those private addresses are carved from, which is another giant private address space. Does that make sense? Thinking a little bit more like a circle, cutting it up. Yeah, cool. Okay. It'll slowly start to stitch together. So Joe's asking, by reading an IP address, how do you know if it's a private address or a public address? That's why we have class A, B, and C addresses. Here you go. This is easier to digest right now. Those other ones get way too complicated for all where you're at. Here are your class A, B, and C private address spaces from top to bottom. If your IP address falls within this space, it's private and not routable online. If it's anything other than this, it's a public IP address. Yeah. Okay, saying subnet is just segments of the network. Private address is like a suite inside. Yep. But you have to specify where in the building you are. Yeah. Cool. Perfect. Cool. That's more of the important parts to pay attention to. Like the 10.0.0. So you can see like the from and to space. If it's 10.0.0.0 to 10.255.255.255, if it's anything within those combinations, it's private. And then from 172.16.0.0, if it's anything from that to 172.31.255, like that space. So the 10 is class A, 172 is class B, 192 is class C. Yeah. They all have purposes. And it's all about number of hosts. So here's another way to look at it. Yes, Apipa. So class A suggests that the first octet is used for network spaces, and then it reserves 24 bits. So 2 to the power of 24. What is 2 to the power of 24? That gives you 16.7 million hosts in a class A network. In that case. Hope I'm doing math there properly. Yeah, okay, cool. There you go. Yeah, it's ton. And then class B networks is taking the first 2 octets and saying that's going to be for networks. And then class C is taking the first 3 octets and saying that's for network. That's why we have those address ranges, class A, B, and C. All what it's doing is just taking an octet and putting it in there and reserving it for network space. So, to summarize kind of this little section right here, just kind of consider that a subnet is a network within a network, and it is made up of IP addresses from one of these ranges. We're gonna take a little break here again, and then we're gonna come back. It might even go like a little bit longer today too, I think. Yeah, child network. So IBA saying private address for subnet. This is like the entire apartment building itself. It has a single street. 123 Main Street. This is similar how a private address network appears, a single IP address to the internet. These are like different floors or sections within a building. A first floor, family apartments B. Second floor, student apartments. Each floor or section has its own unique characteristics and rules. Apartments might have a stricter noise regulation. Yeah, cool. So yeah, I mean, you can look it up like Abe's saying, which is great. Thank you. You could like chop up, imagine like apartments with floors and apartment units. It's still the apartment. And all you're doing is just like breaking it up. And just like the warehouse, the Target warehouse, just like the library with bookshelves, all you're doing is chopping up the available space you have. And you're just segregating it. Now, as soon as you enter that apartment, as soon as you enter that warehouse, as soon as you enter that library, you've now entered a private space. And every time you give a certain portion of that space a location of where it's always going to live, you're giving it a private address. Great sessions. Yeah, thanks, Abe. Senpai, thanks, man. Yeah, appreciate it. Yeah, we really want to make sure that we've got to get that. That foundation is so important. We spend a lot of time on networking. Good stuff, yeah. Zeno, what hosts are left for Class D? So those are actually a little bit different. Class D it's a multicast address. Consider that to be like a stream. Class D is an entirely different type of network, has a different functionality. To go back to these analogies that we're working with, let's go to Abe's. If you had a fire alarm go off, everyone would hear the fire alarm inside of that apartment. That is a Class D network. No one lives in the fire alarm. There's no hosts. There are no hosts on multicast for the Class D type of network. But it is a network that all of the apartments, all the hosts can receive a stream on if configured for it. Yeah. Cool. Hades, thanks for the sub. Appreciate it. I will have some cool emotes for you guys that have subbed. I haven't configured it yet. I just was looking at it earlier today. I was like, oh damn. I believe now you are a defender. I think you should have said that somewhere. But you'll get some special things. We'll get that configured after. Thank you. Yeah, cool stuff. Very, very cool stuff. So yeah, Class D is like your fire alarm kind of going off. Everyone can hear. You want to be in the red team? We're getting there. Doug, if he's still hanging around in chat, he might show you some fancy red team stuff. What else? Okay, so then if we're thinking about if we went inside of a warehouse or library or apartment and we had up to 255 units or books or shelves or what have you, then we would want to go with a Class C network. You know, like, oh yeah, here you go. Okay, cool. All right. If I knew that finding a decent image was that difficult, I would have had these images like bookmarked ready to go. I really thought they would have been easy to Google right away. Okay, so if you had 255, and remember, we have reserved spaces, so that's why it gets at minus, like you lose some values. So truly, if we had 254 things to organize within a space, we would want to create a Class C network, and it would start with 192. Yeah, it would start. That doesn't look right at all. What's going on here? Here we go. It wowould be 192.168.0.0. It's going to fill within that range. And the network ID... Tell me I still have that chart back here. I'm going to have to draw this out after. This is really annoying. Perfect. Still had it open. All right. Close that. Close this. This. Okay. So yes, if we wanted a certain host limit, we would choose one of these private addresses to give an IP address to those things inside of the warehouse or to the shelf or to the department. That's how we would organize it. And it's all just dependent on the amount of space that we can use within these Class A, B, and C networks. Cool. Alrighty. Take another little break over here, but yeah, Doug's gonna jump into a lot of cool stuff. We have threat hunting coming up later in SOC 100-5. So let's look at SOC 100 level effect. We go to our training courses, you go to our training roadmap. We are here. We're still in prepare. We are in the prepare stage, and then we're going to move over to train. And we're going to go through all the good security stuff. And then finally, you're going to learn how to defend inside of a virtual SOC. And then you will certify. You have to test yourself in a 1-week practical. And then we have the advanced stuff. Yeah, this is where all the fun stuff. Reverse engineering, threat hunting, detection engineering, defensive scripting, pen testing, and AppSec, and Python. That's coming out in March. Duh. KS, you want a sneak peek on Tuesday? You're not going to get those peeks until a little bit later. Yeah, SOC 100-2 should be releasing on, I think, the 7th. Tuesday is going to be our sale. We're going to announce our Black Friday sale. And that's going to go until the end of the month. So is passing SOC 100-4 certified? Yes. So Karina, you must pass the SOC 100-4 certification for CDA Live. Yes. Yeah, TT, exactly. Gotta know the basics. So, I like to say that this, like, beginning area, while some of it is, like, shiny and fun, like, I know a lot of you are like, oh, the kernel's super cool and stuff. A lot of the fundamentals, as you go along, like, a portion of it is just going to be, like, you gotta shut up and eat your vegetables. You know, like when you're a kid. and you're like complaining you didn't want to eat your broccoli and stuff. Well, you gotta eat your broccoli. Like you just gotta eat your vegetables. That's kind of what some of the fundamental stuff is. Doesn't taste amazing, you know. Like you want some donuts, you want pizza, and you want burgers, and or a nice steak, lasagna. You want all that good stuff. That's coming, but you also got to eat those vegetables on the side. That's kind of where we're going. So cool. Let's take a break. I will come back, and then we're actually gonna do some subnetting together and kind of just like walk through the process. And then I think we can actually like do one lab before the end of the day today. What's going on in chat over there? So yeah, TT saying might do an advanced course. Yeah, we might. Hades, you think you started Backtrack? Nice. Yeah, Backtrack. Well, cool. Nimbus, thanks for the follow as well. See, you were asking if it's all one track? No, SOC 100-5 is an entire course. Like, it's all those things. It's all those modules. For the last 12 years, I was creating web applications, but I want to break them. Yeah. Hell yeah. Yeah, I think Doug and I are gonna have some fun on this stuff. My background is being a security consultant and pen tester. I like the red team. I prefer it. I think I've talked about that on a different stream. I find it really gets to the root cause of things. That's where it's at. The rest of it's just putting out fires, which is fun, but you don't want to just put out fires all day. You want to start getting to the deep side. Is there a lot of traveling in the red team side? That totally depends. You might just be working remotely. You might do on-site. You might do like physical tests. You might do physical security engagements. You might actually have to get inside of a company. That is heavily dependent. But I would say arguably, red team will have more traveling than the blue team. I think overall. Yeah, I think that's safe to say. Karina's got a good question. So could you explain how SOC 100-5 and CIDR Live compare to each other? Yes. So take a look, Karina, at our training roadmap flowchart. SOC 100-1 to 4 is what we want to certify you on to be able to perform the work of a Tier 1 cybersecurity analyst. SOC 100-5 is a series of modules that are not necessarily dependent on any of the other courses. It is a prep. SOC 100-5 is a series of fundamental modules of very advanced content to prepare you for anything above SOC Tier 1 training. It is a primer. It's like prerequisites. It's kind of like what we're doing now for CDA. It is doing that. It's another set of prerequisites for further advanced content. And once you complete this section here, this is the SOC 100 level of our content. You can then flow to SOC 200 types of training. And that's our CDA program, which is just hyper focused on more analyst triage, and it gets much more advanced. And then you have the DE 100 and our future defer content or the data science tracks. So you can start CDA live and you don't have to do SOC 100-5. It's nice, but you don't need to do it. So the next cohort's going to start at the end of February for the live program. And we want to make sure that like you're certified right up till like I think the start date's on the Monday or something. Isn't it right? Isn't it February 24th? Live training, CDA. Fall. That's not right. Wait, no. That's 2024. I'm thinking wrong. Okay, yeah. February 24th. It's the Monday. So like we've structured it so that for students that just want to continue through the funnel, you would want to start with CDA Live after, which is just like this, but private. Like that's not a live stream. Or you would buy the CDA on demand and just do it yourself. So you kind of have two choices. This is why, yeah. So you do not need to do SOC 100-5 to start CDA. But cool. Let's take a little break there. Karina, I mean, yeah, I get you. Yeah. There's only so much you can do at once. This is why we're going through this like slower. Yeah, I think so. Yeah, CI. We typically do 2 to 3 cohorts a year. Like I said, stay on news for Tuesday. But cool, let's take a break. And when I leave for break, I think there should be an ad. But you should not have been getting ads while I've been teaching, right? Like none of you got ads? Please let me know. Yes, good. Okay, good. Good. I don't want to spam you guys. So, all right, I'm gonna take a little fiber back. BRB. Break over there. All right. Let's get back into this. Okay. Get a good stretch. Some more energy. It's all coming together, everyone. A little bit at a time. A bit at a time. Alrighty. We're almost at lab time, KS. All I want to do is actually now just walk through and like visually chop up a subnet together. And then I think we can do at least like the first lab today. So I think we'll go a little bit over too. It's okay. Take the stream over a little bit longer. Almost there. Where this all starts to stick and you'll be like, oh yeah, that's making so much more sense now. Okay. Okay. Let's take a look at this. I think it's iPad time. That's right, KS. Carrots and the veggies. We're gonna get to the meat and potatoes soon. All right. Okay. Let's do this. Let's open up. Let's make another note. I will find out why that doesn't store my settings later. Get that ready for tomorrow and do all the Twitch stuff as well too. All right. Let's dive into it. We want to make a /24 subnet. This will be a Class C network. Because let's just say we have 200 hosts. And we want them all in the same subnet. We don't really care. So we can use the 192.168.0 whoops. Class C network. And this is going to be using, this is the representation. So the beauty about subnetting is once you actually start to understand this stuff a little bit more, it's almost therapeutic. I just want to say that. It's just like, you're like blueprinting your network. It's like, okay, cool. I want to just like start doing some math and carve things up and put this here, put that there. But we have some network requirements. That's really where this all starts. So we want 200 hosts, and we want them all in the same network. So it's not just like we're sitting here and be like, oh, I'm just going to like use whatever. We're doing this because of strict requirements. We want to optimize and utilize that warehouse storage. So in this case, we want 200 hosts, and we want them on the same network. So that would be a good decision to use a Class C network that has a limit of 254 hosts. Okay, so this is kind of where it starts. So let's kind of break up this network now and see what it's actually going to look like. The network address will consist of that first portion. So, net. Now, we can do a certain like mathematical calculation over here if we want. And this is actually called like the power of 2 rule when it comes to this stuff. Remember, everything's binary is 0, 1, so it's a combination of many zeros and ones, but that's only ever states of 2 possible conditions, 0 or 1. So that's 2 to the power of something. Now we can do a little bit of math. Remember, IP address is a 32-bit address. And if we are using 24 bits for the network, right away, we can say that we have 8 host bits left. Oh, wait, actually, you know what I should say? Two, three, six, yeah. Okay, so that therefore, thanks, Karina. Yeah, I was trying to keep them consistent. So you can kind of see like why I'm referencing these things as I go. So we effectively now have 254 usable hosts on the network. Therefore, we've met our requirements of 250 hosts on a single network. So how does this look? If our network address is now 192.168.0, then, or sorry, .0. Then we can say that go to yeah, you know what? Let's actually give you the broadcast address right away so you can see how that's working. So therefore, those are the 2 bits. Steven saying, message in the SOC student, it would be cool if we could figure together and figure something out. Sorry, didn't mean get off topic. What are you? Student. Oh yeah, that's cool. Yeah, I recommend everyone like go make little study groups. Go study, like Steven and others get together. Go and just spend like 30, 40 minutes an hour with one another, like once a week or more if you can. And just talk about the stuff that you're learning. Remember what I said in the beginning of this course. This is like a learn one, do one, teach one, learn once, do once, teach once. If you're just stuck like in your own head by yourself, that's you're going to progress a lot slower than the people that are getting together and doing that teach once part at the end of it. The ones that are teaching one another. That's like super accelerated learning. So please go ahead and make sure that you're getting together and you're actually combining your efforts. There's a saying that many hands makes light work. There's a reason for that. Cybersecurity and IT is a team sport. Keep that in mind. None of you are going to be able to learn and memorize and master every single topic and thing inside of SOC 100 alone. And it only gets harder and more complex as we go. So you need to combine your strengths and efforts together. Do some coordination in the channel. Let me know what you all need. If you need separate little rooms, I could make some little small like voice rooms and private student rooms. Happy to. And then just hop inside there whenever you want. I think there's actually some already, isn't there? No. I will make you some SOC 100 student voice rooms you all can hang out in. Yeah. And EDU saying, yeah. You gotta rely on that rubber duck as well, too. Art of a fold together like Voltron. Yes. Yes, yes, yes. Do it. You know, if you're really old, Captain Planet. Really old. Okay, so we have a broadcast address using the last available space We have our network address as the beginning, therefore we can't use those. So therefore we have 250 hosts that we can dish out inside here. Now we have this DHCP server is now configured with this information. And this is going to be your router or switch at home. And now it has the usable space to hand out on the network. And this is how we get the first address. Oh yeah, too. Yeah, Cass. Like, I mean, if you don't want to network in the SOC 100 channel, it's fine. Like, if you just want to hang out in the Level Effect Discord or even outside of that, that's totally cool. However, whatever you're comfortable with, just as long as you're working together. But that's what I wanted to be able to show and demonstrate. Okay? And that is, to make it even more clear, so now, does that make more sense? Now, like, looking at how I just kind of walk through this, this is what subnetting is, and this is what IP addressing is. If we wanted a 200 host network all to be in the same network, then we could use a Class C network where the mask bits are the first 24. And the last 8 bits are the host space available. Oh, I should also say, which creates a subnet mask. Sorry about that. Did I? No, go back to subnet mask. That covers everything. That's how you get your IP address. Did anyone not follow along with kind of like the charts in the demonstration that I was doing? Generally. Like, I'm not asking you, like, did you follow along to the point where you can reproduce it on your own right now? Which is not going to be possible. But did you follow along enough to understand the flow of what happened? Anything that's unclear? He's followed, but already knows it. Yeah, that's cool. All good. That's good. Yeah. So Steven's asking why it's not 255. So, and that's actually part of like the broadcast section. Where did I write that? So the broadcast address is always the last usable space, last usable address. In this case, if we have, if you have 256 possible hosts, minus the network address, minus the broadcast address, you get 254 hosts. Now, the broadcast address is just going to be the one after the last amount of usable hosts, which in this case is going to be 255. And counting starts from 0. Pry, good question. Yeah, so what's the IP address of the router or switch? Typically, in good fashion, the router or the IP is actually the first usable IP address. Typically. Now, enterprise networks are a little bit different. They use their own internal naming conventions because the router has an IP address as well. The switch usually will as well. And some companies will use like .10. Like all their routers will be like .10. Or their switches will be like .5 or something. But for the most part, it's going to be your first IP address. And that's actually the gateway we talked about way back. So this is why when you see like an IP address output, you see what is the default gateway. The default gateway is your router. Yeah, we're going to actually, I think we're going to be able to pull up the IP address lab like right after this and kind of demonstrate this stuff. Markley, thanks for the follow as well too. Did I answer your question, Pariah? Good stuff. Yep, that's right, Abe. Yeah. Then your network administrator, your system administrator, is the primary person for this. They're responsible for mapping this all out, architecting it, thinking about it, testing it. So like if you're starting off as like a level 1 type of analyst, help desk analyst, you should generally be aware that these networks work. But this is not like your day 1 responsibility. This is why we're just trying to get you to understand this stuff. And the goal of why we need you to understand this is so that you understand how and why endpoints can or cannot talk to one another. which I hope you can generally answer this point. If I have... So if I have an IP address that's not on this subnet, and it's trying to talk to another IP address on this subnet, like the 192.168.0, where do you think the problem would be? And think about what connects the networks together. Yeah, sure, Joe. Maybe I'll actually just kind of like draw it out. So if I had subnet A, this is a question that you might actually get like on your Network Plus exam, by the way. I'm not even kidding. Let's expand the question even more. If PC1 can't reach PC2, what do you think's going on? Give me some possible problems. Give me any type of problem you can think of. Like, what could happen? Think about everything we've learned. From the OSI model. From 7 down to 1. Nodes, switches, routers, endpoints, IP addresses, all that stuff. Yeah, good. Good, Karina. Something's possibly going wrong with the routing. Bad connection? Yeah. Be more specific, CI. Well, like, what would, that could mean anything. What is a bad connection? Kim Fried says device is offline, cable is damaged. Yeah, good. Perfect, good. Very good answers. What else? Mac flooding? Yeah, more advanced, but yes. What could go wrong with the MAC address, aside from MAC flooding? Remember we talked about the process with ARP, Address Resolution Protocol? Just like, keep firing, I want to know more. Tell me what else could be going wrong. Mm-hmm. Awesome, Karina, yeah. Switch might not find the MAC address. Man in the middle. EDU saying not sure has been covered, but the IP address may have changed. Perfect. ARP table referencing previous address. Perfect. Can't find the MAC address. Awesome. You see what we've done? We've been doing a whole lot of wax on, wax off like Karate Kid. This is a question. It might be a little bit more detailed on the exam, but this is like the type of question that you would see on your Network Plus exam. Now, it might just give you a little bit more context. But this thinking is what those exams are trying to get you to think, and that is why I still always say, like, there is benefit to studying for those exams, because this is what you're going to do in the field. If PC1 can't reach PC2, you need to start troubleshooting along the OSI model and thinking about all of the little things that are involved along the way with IP addresses and MAC addresses and DNS and ARP and switches and routers, cables, subnet masks, you name it. That is what is going to happen to you in the field. Change subnet mask from 24 to yeah. Weird point, but it's possible that these subnets aren't allowed to talk to each other. That's also possible. Yes. And that... So Jay, where would that happen? AJ. Hades says firewall, access controls list, yeah. Network address translation. Yep. At the router. Yes. Yes, perfect. Good. Yes. Remember chat, everyone else here. If one network can't talk to another network, networks speak to one another by IP address connections via the router. Start with the router at a high-level overview like this. And then start poking and prodding along. Like, is my subnet mask configured properly? Do I have the right IP address? Firewall rules. Whole bunch of stuff. Yeah, inbound, outbound rules. You see? It's, yes, exactly, Steven. It's all coming together. It's all adding up. It's all layering on itself. It's almost like there's a reason why we call them OSI layers, right? So what could be wrong with routing? Yeah. Well, maybe the router is not configured. Maybe it doesn't have the actual configuration to reach another subnet. Maybe there's a conflict. Maybe it has the wrong IP address, or the wrong network address for subnet B. Maybe there's a firewall rule that says anything from subnet B, drop it. And this could all just happen from like human error. Someone types in the wrong thing, or maybe something didn't update. And yes, it could be as simple as a bad cable. Highly unlikely, but it does happen. It's happened to me, and that sucked. It can happen. Cool, huh? No, CI, we didn't do Nat and Pat yet. Yeah. Awesome, though. Like, these are the responses. I've been saying some antivirus problem. Can interfere with network connectivity, try disabling them temporarily. Yeah. Yeah, wait until we get to, like, the endpoint software stuff. Prize saying, did I miss firewalls and NAT? No. No, you did not. You just haven't done it yet. What if it's not a router, but just a hub? Yeah, I mean, if you don't have a router, but you have a hub, then it still should be able to get over there, depending on the smartness. Depending on if the hub can actually support IP address routing. At that point, your hub might just default and put both your switches on the hub connections, and it'll turn into just a MAC address connection at that point. KS saying rogue device in the network. Yeah, exactly. You had a rogue... So KS had a rogue device on the network that was conflicting with IP addresses. That's another problem. What if PC2 has the same IP address as another PC? What if it has the same IP address as PC3? That's also a possible problem. PC3 is not even here, but what if it was? Kind of looks like a rogue PC over there. AD saying, Abby saying, passing ARP cache on needs to be ensured it has correct MAC address. Yeah. ARP cache could be corrupted, it could be confused, could be expired, it needs to be updated. ARP is not actually working properly. I had that real world situation where the company VPN tried to apply the same IP address to my connection as my laptop already had. Yeah, exactly. And you probably couldn't even get connected properly. Both of those IP addresses, you and the other one, were probably stuck. Router gets confused, yeah. J-Ray is saying, yeah, just do ARP spoofing. Yeah, make the switch burn. Catch it on fire. Awesome. This is where it starts to get a little bit more fun. You can start thinking how to troubleshoot. Yeah, I mean, yeah, use traceroute. We're gonna be doing that. Cool. All right. So I want to fire up one lab, and then I think we can hop into more stuff tomorrow, because I think that's a good amount of stuff to cover. I'm not going to get into more advanced subnetting. Maybe not today. Maybe I'll just even like stuff it in tomorrow. I think that's a good spot to stop, like with the lecture stuff. I want you to actually go and look at your IP address. Maybe we'll do like a little bit of IP and DNS, just like right now towards the end kind of thing. So I'm going to go inside my SOC 100 course, and I'm going to actually fire up both my VMs. I'm going to fire up the Linux and Windows workstations. So many tabs. Yeah, Jay. Ping could just be disabled. Now, you can still connect if ping is disabled, but that can also be a little problematic too. We're actually going to learn about that. Cool. You JavaScript, thanks for the follow. I love your name, by the way. You JavaScript, I agree with you. That's how I feel when I see JavaScript as well. All right. And we're going to go over to the first lab. It's actually getting our hands dirty. Finding your IP address and host information. Hades, yeah. There's a break. There's a break in the connection. Nice. You saw it. You saw it. Hades, you're now a VIP. I just added you. Also, because sub and stuff. But just thank you. That was awesome. Your link should work now. Layer 1 issue solved. Yeah, JavaScript. Cool. All right. So we're going to start off. It's going to be a little basic at first, all good, but we're going to be looking into running some actual commands. We're back on the command line in Linux. We're going to be looking at IP address in A. We're going to be looking at our network adapter. This stuff is going to start making a little bit more sense. Look at our host names, host file, quick little spring into that stuff. And then we're going to do a little bit of DNS as well. Okay, so let's go. Let's actually connect to your Linux workstation. Cool. All right. Back on the command line, our Ubuntu account. So we know what our IP addresses mean now. We know the importance of them. Let's actually go and start running some commands. So a couple things we can do to kick things off over here. We can use the IP command. A couple different ways. Remember this. We're going back on the command line. We can run a what is. We can look at the man pages. Get a full scope of our IP information, and don't forget, if this is you start having a little bit of trouble getting back in the command line, you can always go to something like explain shell and get a direct reference to the man page as well. So don't forget about that. But we're back in Linux territory over here. So we can actually use the IP command to determine IP address information about our host. So now let's do some troubleshooting, right? Let's try to find out, like, what is our IP address? So if I were to run something like IP address, we're going to get a whole bunch of information. Whole bunch. Let's get up to the top. Keep going. Okay. So what are we seeing here? This starts to look a little bit more scary compared to the little happy color-filled drawings on the iPad, right? What in the hell are we looking at, right? So what we're trying to determine is our IP address for our network adapter. And you would think, like back in the day, endpoints had just one network adapter. That was it. Just one. That was a long time ago. We are now in the world of many network connections, and one host can actually have basically unlimited IP addresses. And as long as your IP address, so like let's kind of walk through this, this chart over here, we can see this little number here on the left-hand column is actually our interface identifier. It has like a value. And imagine these are like physical network cards, but this is a virtual machine. So this is just code. It's just, remember we're in Linux, everything's a file. Everything is a file here. Remember back the kernel we were talking about, how we can kind of like load drivers when the operating system initializes? What's happening here is when Linux is booting up, we actually have these files that act as network adapters. And they have information on them. And they are loaded into kernel space and hosted over there inside of memory and saying, this process, like this thing that's running, is a network adapter. And it acts like one. It's a virtual. So you're going to hear this term being thrown out of a logical connection. Logical just means that it is a virtualized connection. It only exists within code, within inside of this operating system right now. If I turn off my Linux machine, it's gone. It doesn't physically exist. If I reboot, it might change. It only lives while I have my operating system up and running. So we can see these numbers on the left hand here represent an index value of all of the virtual network cards we have. And a lot of this is configured, a lot of magic to make this all work for you. What we're interested in is something called ENS5. Now, this is a type of standard naming convention for like an Ethernet connection that we're trying to simulate over here, like a wired connection. And 5 is another common naming convention, but this could be anything. This could be a much higher number. Just understand that this is essentially like trying to virtualize an Ethernet network adapter. So you're also going to see a whole bunch of information around it, so we can clean up this output and we could actually start using some short forms. So if I want to do something like IPA, that would give me the same thing, which is also the same as IP address. Now, if I wanted, I could do IP address, and if I hit tab, remember tab autocomplete, we can see the available options for us. So I can do IP address show. In this case, actually, what I want to do is show ENS5, and you can see it here. So if you weren't sure, you could always kind of like tab your way. You can tab your way to happiness and success with Linux if you want. So IP address show ENS5. So let's just do this. And this is the same thing as saying IPA show. And as you get more experience, you're just going to start using shortcuts as much as you can to make sure you don't fatigue. And being lazy is good in tech. By the way, chat, you want to be lazy. Very lazy. Okay. So IPA, let's just show our Ethernet connector, because that's what we're working with here. The rest of these virtual network cards are for a lot of like Amazon Web Services, like AWS Cloud Services and such. So I guess let's kind of break this down and kind of see what we're looking at over here. We can see, based on some of these tags, that we have, this supports broadcast. Remember broadcast? This is saying that this network card will receive broadcast addresses. That's how that blast from the switch on 255, like across the board, like, hey, who has the MAC address? Well, what's going to happen is, if we were trying to figure out the MAC address for our Ubuntu, like our Linux connection, which we can see our IP address right here. what's going to happen is the switch will dial out to everyone and say, hey, who has 02 F4 E2 1070 B7? Linux here is going to say, that's me. Hey, that's me. Or rather the other way around. It's going to say, I did that backwards in my head. It's going to say, what is the MAC address of whoever here is 10.0.21.67? And then Linux is going to respond back and be like, hey, actually, this is my MAC address. It's 02F4 E2 1070 B7. Keep that in your MAC address table now. And next time another computer needs to get a hold of me, you can keep that information too. Now we can speak on layer 2. It's fast. And all of that is because this network adapter supports broadcast. If it didn't, it wouldn't work. So if you were trying to like troubleshoot or debug, you would want to analyze and look at all of your network adapter information over here. It also supports multicast. We talked about that with like class D types of networks. So this is a type of network adapter that if we had like that fire alarm going off and everyone needs to be notified of everything regardless of your networks, this supports multicast. Finally, we have this thing called up, and this is either going to be up or down. Now I'm going to pause there for a moment because you're actually going to hear a lot of reference. You're going to hear a lot of reference to that when it comes to networking. Is the device up or is the device down? Is the network adapter up or is it down? Is the state up, state down? So you're going to hear that reference, that terminology. That's why it's used here. So you're going to hear and see this. So ENS5, our network adapter, is in a state of up. And then finally, we're going to see this last supportive connection over here. These are flags. Like these are operational flags of our network adapter. And this is saying that the physical or like the wire is active. So going back to Hades and our little diagram, the secret all along was that the cable was actually broken. Right over there. I mean, just for fun. So if that was the case, then it would actually not state this. I think it would actually say like lower down. So that's how you can sort of see what is going on. We're just like working through the troubleshooting of what's actually happening over here. Now, there's a lot of other more advanced stuff that we haven't fully talked about, and we're not honestly going to be getting into this because this starts getting much more advanced. But these are supportive qualities and features and capabilities of the network card. It can get very, very complex, but we actually have the ability to craft and shape like size of network traffic. And this is where you start getting into like network engineering and administration, tweaking and tuning your network. Maybe you want to limit the size so that it doesn't get bottlenecked. Because remember we talked about when we get to OSI layer 1 and we start to route traffic between connections, it's kind of like jumping on the highway. Imagine if we had a highway and it was just full of massive transport trucks. Slow, stopping, taking a lot of space, and then your little 4-door kind of family car to get around tries to get on the highway and gets stuck inside there. That's kind of what happens with network problems. So we have these network administrators that optimize and tweak these types of features to increase performance or for specific requirements of network demands. And that's called traffic shaping. And it's actually called quality of service. Kelbrand, what's going on? So you once encountered 2 cheap NICs from the same vendor that had this. Yeah, this had the same MAC address. See, like there you go. That caused a few issues until you tracked it down. That's so brutal, but like things like that happen. Yeah. Pretty fun. Can't believe that happened. I'm sorry that happened to you. That must have been such a pain. Because that's pretty rare. Wow. Yeah, all of this, like this whole networking world, as we sort of alluded to when we first started, is essentially like a giant house of cards. If there's 2 of anything, like that there shouldn't be, like it all just starts to shut down. It's a very, very delicate, finicky, and picky thing. And it could very easily make your life hell. Like that. Like Celebran. Cool. So let's take a look at some more of these things over here. And the stuff that you need to know this time, be worried about, well, here is your IPv4 address. Here is your /22 network. There you go, CIDR notation. This is a different type of network that you've seen before. This is not a /24. This is a /22 network. So how many bits out of the 32-bit address are dedicated to the network address? Pop quiz. Oh, the computers are down the hall from one another? Okay, that's not too terrible. Oh, damn, sorry. I had the iPad up. Okay. Thanks, Jay. Yeah, so as I was saying over here, things that you need to be aware of are effectively like this section down here. And we have network engineers that optimize and tweak these flags and these configurations of the network adapter for more performance or requirements or features. That's their job. You are probably not going to be involved in that unless you're going like the network administrator, system manager view. If you go that way, then you're going to be the one like getting used to this kind of stuff. If you're a sysadmin, you might be a little bit involved as well too, especially if you're like the sysadmin and network admin. So you'll get more involved with that kind of stuff. What you need to know getting inside of like your IT kind of help desk type of job when you first start and going towards side of cybersecurity, you need to understand to look at a network adapter and determine if there's anything wrong with like these types of main flags. What is your IP address? What's the CIDR notation representation of it? So it's a /22 network. And that's about it. That's about it to make sure that it's all making sense and working and up and valid. If you're having a conflict, you're trying to reach another endpoint, well, is it a /23? Is it on a different network? Is it in the same network? And you have calculators to check that for you to make your life a lot easier. But my question being, if we have a /22 network here, how many bits out of the 32-bit IPv4 address space are dedicated to the network address? Yeah, 22. I think, Calibrina, you're thinking backwards, like hosts. I'm not asking for host space. Yeah. Yeah, it's all good. Yeah, Xeno 22, Joe M 22 bits for network address, so 1022 hosts. 2 to the power of whatever that might be, yes. Can't do that mental math. It's out of my head. I think it's more than that. times 2 times 2 minus. I can't do the minuses in my head right there, but yeah, 2 to the power of whatever. Like you would kind of work backwards. Yeah, 2 times 10 minus 2. Yeah. That's for hosts. So pretty cool. So we're in a /22 network. We have our IP address. We have our ENS connection at that point in time. So that's one piece of the puzzle. Now, when we're inside of a network, we humans, we like names. We don't like IP addresses. We like names. So we might actually be trying to reference things through host name. So on top of the IP address, we have something that is local to the workstation itself. And this can change to whatever you want it to be. But this is actually now our host name. And by default, it could be generated whatever. In this case, it's saying that our host name is actually just the IP address over here. So, another question. We're back at resolving host names. What protocol do we need? While that's opening up, I'm going to go to Windows as well. What did we talk about so much? We're back to resolving host names. Yes. Yes, good. DNS. Back to DNS. See? It's all coming back. So, if I were to go to something like cat etc hosts. Took a while. So remember that Linux, everything's a file. So there's an etc hosts file that actually stores local DNS resolution. This is where it is. Remember when we talked about the DNS recursive lookup process? And I said, what does it do? It looks at your computer first. And it tries to retrieve where something is stored, maybe on disk or maybe in memory. Here you go. So if I were to go inside of etc hosts, and if let's say I wanted to like change the address of like Google or something. Your computer is going to look this file first. And if I try to go to google.com, it's going to try to resolve the 10.10.0.5. So if you have a user, and this is common like in big networks and old companies with like old technology, they have their host files set up with specific internal IP addresses that are always going to be the same. And it's faster for your endpoint to have that information. Tiny question there. Doesn't it need to save its own host name within etc hosts? No, I don't think so. As long as you have local hosts, you're good. So 120. So if I try to reference like local hosts in the browser, that'll load the background. We're going to get to ping in a moment. But you see over here, the fact that if I try to ping localhost, it knows to go to that address. And it knows how to get there because I've told it I've told it that when you try to connect to local host, you always want to go to 127.0.0.1. Just as if I went inside the browser and I went to localhost, it's going to try to connect to me. Now, I'm not running anything. Like, there's no network service that I'm running. But if I were to go like to port something like 8080, I'd be connecting to myself. In that case, on port 8080. So the host file is actually really important. This is going to look different, like from network to network, but this is where you'll start here when you're troubleshooting DNS when it comes to like a local DNS resolution problem. You see it like starting to actually kind of click and connect over here. Now we can also kind of mess around. If I wanted to know like my primary IP address, I could just run like a hostname tac-i command, and it's going to let me know some of my primary IP address connections, and it's going to list them all, mind you. But there's more commands you can run, and again, this is where we start getting back to like scripting territory and try to figure that information out. Or we could maybe do like a control R and that old command over there. IPA show ENS5 would be, in this case, a nice way to be able to see our IP address. Now, fortunately, cat etc reads the file. Sort of. CI, you might want to go back and reference like the Linux portion when we talked about concatenate. But essentially what it is doing, it is opening up a connection. It's reading the file, like it's dumping the output to a terminal via standard out. Cat is a command we can use to read files as like a shortcut. Nice EDU. Yeah, you're gonna have some pretty cool commands. You can do like hostname, tac-i, depending if you have like a whole whack of stuff. You could just awk it if you really wanted. And we're gonna, like, I think we're not gonna get too deep in the weeds of like scripting and things here from a network perspective, but there are many ways you could do this. So, however you want to actually do it is like whatever really works for you is the best way to do it. There's lots of like nice little handy shortcuts. So let's go take a look at EDU's command over here. So we've got, we're gonna run IP command, brief. We're also gonna do all the IPv4 addresses you have over here and just show the addresses. That's kind of neat as well. Like a nice little output. Oh yeah, fair enough, Jay. That's good to kind of expand more on CI's question. I didn't think that she was mentioning like reading the directory, but yeah. So cat etc hosts. So hosts is the file inside of etc that we're reading. Yeah, thanks for highlighting that. Just to be like super clear. Now, how would we do this on the Windows side? So let's go on about the CMD prompt, and it's pretty similar. Now, I was over here in Linux, and you could also use like ifconfig. Ifconfig is another way of getting information. I personally like the IP command, but in Windows, we're going to be looking at ipconfig. So I think we've all done it. Like whenever you're like going back and forth, you're typing it like, why isn't it working? You're like, oh yeah. It's ipconfig and ifconfig. So close. So ipconfig is how we would do it in Windows. And Windows actually, like, it formats it a little bit nicer. I'll give it that. So like here you go. Here's my IPv4 address, my subnet mask. So this is that /22 network. Remember the bits being set? Or actually, no, I don't think that's a /23. I think. And then default gateway is the router. Like that's our connection. We're actually trying to connect out to. So you can do some fancy stuff as well, like ipconfig. Remember find string and stuff that we could do. We could do that with like attack I, and maybe we want to just like search for, and you can do this in PowerShell. There's lots of ways you can do it, but essentially you would just run like IP utility commands, PowerShell, Bash, or CMD to find the information that you need. So you could just like scrape out that line. Again, my preference is going to be Linux for me. It is just much easier to get the information that you need. Also, you could do like ipconfig/all. Those of us who grew up with Windows, you're probably playing with here quite a bit. But this is how you get like a full output as opposed to just the ipconfig. So you can see like it calls it Ethernet adapter 3. On Windows over here, that's different. Linux is like ENS. So you're going to see that there are different naming conventions for these types of things. So you would start there. You can see our DNS server is 10.0.0.5.8. So this is where it's going to try to connect to first. It's going to hop out of the network. So this is 10.0.0.16.1. That's our router. And it's going to hop out of the network whenever it needs to try to connect to a 10.0.0.5.8 DNS server. Now, remember, we talked about having like possible DNS issues. This is where you would go and flush the DNS record. So we would go to something like ipconfig/flush DNS. And this would solve problems. Like from a Windows side. So we'd want to go inside there. And the Windows file, if we want to actually pull up like a visual view. Windows has a host file too. Windows system32. And I believe they also have, it's in drivers, right? Drivers, etc hosts. So Windows has, you can see like they're mirrored. And remember when I was talking about the beginning of networking? The most important thing to understand about networking from an IT and security perspective, and more so security, is that it's a standardized protocol. And Windows might look different with logs. Linux will look different with logs. Mac, all those operating systems and phones, they all report information in different ways. But networking is universal. How data is structured over the wire is going to be very, very similar. It doesn't matter where you go, from endpoint to operating system. And that's how we can identify threats. That's how we can rule out issues quickly. Because there aren't as many combinations of possible ways to format stuff. And this is why we spend so much time on it. Because this is where malware is most likely to get spotted. Like malicious activity, we can catch it over the wire faster. It's a very strict protocol. There's only so many ways you can present it. Windows has a host file, just the same. Linux has a host file. Mac, like everything has a local DNS resolution. Jay's saying, wouldn't we run out of MAC addresses eventually? Yeah. Same thing like IP addresses. It doesn't really matter. You can just use things locally. Like you said, MAC addresses are for local network resolution. So while it's nice, if you need to really trace something down to like the vendor, cool. But, I mean, truly, it's not the worst thing in the world. You can just kind of reuse MAC addresses as needed, unless it's something really critical. And then eventually you just expand the space as well. Or change the protocol around. But I like the way that you're thinking. Yeah, like it doesn't really matter because it's not going outside of the network. Cool. And then, yeah, Linux side, you can sort of do the same thing. You could run something, you could actually interact with systemd. Remember we talked about the systemd service? We can interact with it via system control, or you can actually call systemd itself in this case, but like sudo system control, you can restart the system d dash resolved. So you can like flush your DNS service very in a different way with syntax, like the structure of the language, but it's the same objective. If I'm running into a DNS issue where I can't resolve a domain name, I'm going to look at the etc hosts, and then I'm going to flush the DNS cache. And if I'm having a problem with IP connections going on, like the good old iPad, well, is there something wrong with the IP address? Is it on a different network? Subnet mask? Is the slash notation off? Does it have the same IP address as something else? And then you move up from there. If that's not the problem, then go check your switch, check your router. You just kind of work through it. That's really it. Cool. It's a good spot to stop for the day. Finally hopping on a lab. So now we're starting to see this in action. I think we'll stop there for the day. Good spot to stop. No, Jay. So maximum transmission unit, that's the size. Time to live is not. That's like your time to live, like how long it's actually going to be living and valid. Everything has like a time expiration. How long the transmission can be sent out before it just gets cut off, like we don't care about it anymore. How long before it's just expired. How many hops or how many times we can hit another router. They all have that TTL, time to live. Cool. Making some progress on networking side. Yeah, or double. Yeah, things got heavy. Subnetting is the heaviest thing. From here on, it starts to get a lot easier. I think, so R double, I think the best thing you can do is go back through this, maybe start asking some questions to maybe some of the other students in chat as well, to try to like go through this material a little bit slower on your own. And it might make a little bit more sense when you have to try to explain it to someone. Jay, I don't think MTU specifically. I think that's one piece of the puzzle. That's one piece. Like if it's a certain value, you could say, okay, cool, like that's an Ethernet connection, and or like that's a wireless connection. Like it could help you track it down. And if you were to say like I have a 1500 size with like a 15 TTL, then it's going to get me closer to this endpoint. I think it's like fingerprints. It's pieces of its characteristics. KS, yeah, drop it in chat, and drop it in Discord too, please. I think subnetting is like you saw how I did it like on the iPad. Subnetting is something like you need to do. You have to physically do it. You have to calculate it and draw and draft it out. If you can't just listen to someone. Yeah, Karina, I'm gonna post the drawings. It's easier for me to scrape it out of this new app as well too. I'll put it inside of the SOC 100 course. MTU can also be changed. Yeah, you can change the size. I remember we talked about traffic shaping. And DT, we're taking this in bits. We haven't got to bytes yet. Cool. Day 8. Day 8 down. We got a long way to go. We're on day 8. Plus some more live streams we're going to do. There's like another 20... No. There's like another 16 or 18 live streams. Yeah. Yes, yeah, new M4. The new M4s are crazy. I'll put inside of Discord, but the M4 Max, the benchmarks that came out of that, it's more performant than a 4070 I've seen. That's pretty nuts. And it's not a dedicated GPU. Thanks, Hades. Thanks for the sub too. Appreciate it, man. Thanks for being here. Thank you, everyone. We're gonna cut it off over here. And I think that's a good spot to stop. That was a lot to take in. Thank you, everyone, for attending, being here again. And tomorrow, we are going to continue this. We're just going to keep pushing along. 10 a.m. tomorrow. And I'll send out I'll put out some polls and things. I want to get a feel. Like, does everyone want to do this at a different time? Kind of feel it out. Abby saying, quick off topic. Yeah, it's pretty easy. I use OBS. And I use Air Screen Mirroring Receiver, which allows me to share by AirPlay my iPad screen. DT saying it's going to get a little bit more intense depending on if you're going to threat hunting. Yeah. Very, very cool. Karina, thank you. Thanks, Jay, Senpai, Abe, CI, Patricia. Thank you all. Happy Saturday evening. Everyone else, go enjoy the rest of your day and night. Go relax. And the recording will be up as per normal, like 2 days. And we'll see you tomorrow morning for Class 9. Class 9 of SOC 100-1. Thank you again. Have a good rest of the day, everyone.